Okay, so let's start. Welcome everyone. This is day 2 of the online pitch of the Client Solutions track. I'll just share my screen. Can you see my screen?
Yes. Yes.
Okay, great. So I think most of you were already here yesterday, but just in case if there's someone new, I'll just go quickly through the presentation. It will take 1 minute and then we can start with the pitches. So we are in the last selection phase before the bootcamp. The purpose of yesterday and today, the online pitch, is to select the startups that are going to participate in the bootcamp in the next phase. The bootcamp will take place in Lisbon from the 3rd to the 5th of December. And today's structure will be, so we will be here for about 4 hours. And each startup will have a 10-minute slot in which they will present their pitch in 4 minutes. And then we go for Q&A for 4 minutes as well. You can either write the questions in the chat or unmute yourself and just ask them directly. And then we have a buffer just to make sure we are on time. And so the lineup for today we're going to have 21 startups presenting. So grab your coffees because it's going to be intense. And we're going to have 3 breaks. I'll let you know when we have the breaks, and I'll also announce the startups. And I think we can already start with the first one. I can call already the first one, Aegeus. João, you can let them in. So let's go.
Got it.
Hi, Suraj. Welcome.
Yeah, welcome. First of all, Ola.
Good morning. Yeah, you have. So we are here with EDP, and you have 4 minutes to pitch. So go ahead.
Ola, and good morning. This is Suraj here. I'm the founder and CEO of Aegeus Technologies. I came back to India beginning 2016. Until then, I used to run a global P&L for a US multinational called Eaton. Before that, I worked for General Electric, GE in different roles and geographies. So Aegeus is a IoT-driven green robotic solution provider. We're harnessing AI and ML. We're a robotics company harnessing AI and ML to see how we can, automate the entire operation and maintenance of large solar farms. Our flagship product is the intelligent waterless solar panel cleaning robot. We boast a efficiency of 99.84% cleaning efficiency, the best in the world. We got patents for our cleaning system. We're only company in the world with the patents for a cleaning system. We got our patents in US, in India, in China, Australia, Saudi, and all the large markets. We are the only second indigenous design in the world. And hence, you can see that there is this kind of a difference between everybody else does what we can see on the left-hand side and what we do is on the right-hand side. This is a live site. I mean, this is not a picture or anything. So while we were, doing this, while we developed this water solar cleaning robot, we also realized that the operation and maintenance of large solar farms is broken, and there are various other challenges. So therefore, we've developed many other products which can help automate the complete O&M. On the right-hand side, you see Unicorn, which is the one for the large solar farms. The one on the left-hand side is Shreem, which is for the rooftop. On the top, you see is autonomous guided vehicle. So we're deploying these computer vision, motion planning, machine learning, image processing. So we're deploying various technologies to solve, some of the challenges like reducing the soiling, monitoring the electrical installations, vegetation management, which is basically grass cutting and what have you, periphery surveillance. So we're trying to automate the complete operation and maintenance. But as I said, our flagship product is this waterless solar panel cleaning robot. I mean, we got our central monitoring software called as Access Connect, which connects various products, and you can help in predictive maintenance. This is Shreem, which is for the rooftop installations, which is almost 14 kilos, 15 kilos. And you can see the cleaning efficiency on the right-hand side. This is the autonomous guided vehicle that I spoke about, which is helping in terms of monitoring these electrical installations, like, the back of the panel, the junction box. You can also monitor the mechanical, connections. We got more than 8 gigawatt of installations in India, in Saudi, and we're now entering into the Brazil market as well. So yeah, and we already mentioned about the patents in different parts of the world. We were the market leaders in India for the last consecutive years. We backed up with a strong team of engineers. As I said, I bring about 25 years of experience. We have got a large team of developers and experts in robotics. As I said, so one thing which is very, very unique to us, as I said, is the cleaning technology, and that's what makes us different. We have been approved by all the leading module manufacturers. We've been approved by large developers like Aqua, Masdar, Deva, Samsung. We're working with some of those companies. And we look forward to working with EDP. We're already having some basic interactions with EDP in Brazil. Yeah, thank you so much. I'm open for questions.
Thank you, Suraj, and thank you for respecting the timing. Yeah. So now let's go for Q&A. We have questions.
Yeah. Hi, this is Carlos. I work in the DG business, distribution generation business for our rooftop, and we have PV plants in rooftop and on the ground. Regarding your machine, your robot for the rooftops, the main issue we have is in some cases we need daily cleaning, because we are really close to the cement plants or this kind of other facilities. They produce a lot of soiling. How autonomous is this robot? That means it's possible they automatically work every day to clean the modules in remote, or how this work?
Yes. We, in fact, for the cement plant, 60% of the cement plants and coal ash plants where there are solar farms, we do them in India. We've got our technology is best suited for that kind of application. In the picture, you see that's again, cement plant. You see the one. So this is a rooftop installation which is close to a cement plant, and this is fully autonomous, whereby there is no manual intervention required. You can set the time of the date. When you want to clean it, it will automatically go clean and come back and sit into its dock station. Yes, it is fully autonomous. If it rains, it will not come out. If there's a heavy wind, it will not come out. So it's a fully autonomous machine which can clean your rooftop.
And they use water, or there is only clean with air, or with the machine?
Yeah, with them, it's what we call as air wash technology is our patent. It does not use any water.
Okay, thank you.
Can I ask a question regarding you're saying it's fully automated, but usually in rooftops you have gaps between the sets of solar panels, right? The strings. Do you require someone to move the robot to the next string, or how does this robot navigate from string to string?
Yeah, so both are possible. If you want, because it is just a 14 kilo, 15 kilo machine, if there is a manpower available, then they can lift and shift it. If it is not possible, then we can create those bridges. So the machine is smart enough all you need to give is the layout drawing. It will make its own path. And only thing we need to do is that then provide the bridges.
Okay.
Yeah.
Because like you all say, we have a space, a ace between the strings, like a 50 centimeters for the maintenance ace, and that's the reason you need to jump from one to another one.
Yes. So if you provide the bridges, it will move over that, and then it will move from one area to the next area. If there are any bridges, if there is no possibility, then you have to have multiple robots.
Okay, and why does this solution need to be different from the ground? Why does it need to be different?
Sorry, can you repeat?
Why does the rooftop solution need to be different from the ground solution?
Yeah, so rooftop, the weight is a bigger challenge, because accessibility of rooftop is a challenge, carrying that is a challenge. So therefore, this is our, ground mount solution, which is for large solar farms. You can see the
This
picture.
is fixed, right?
Yeah,
this is
fixed. So this also can be done lift and shift.
okay.
Yeah. And this one is for your ground mount rooftop installations. So we have ensured that it is a light, compact, you can carry it in a backpack.
Okay.
Yeah. Otherwise, you need a crane and a big machine equipment to move that's not the case. You can carry it in a backpack and go up and then do the cleaning. So we have solution for any challenge as far as rooftop, whether it is rooftop or ground mount cleaning.
Okay.
Yeah. I mean, we've got more than 9 gigawatt as we speak.
Thank you so much, Suraj, for your presentation and for answering our questions. We ran out of time, so thank you for being here. And we'll let you know the results in the next weeks, okay?
Thank you so much. Thanks for your time and really appreciate calling us. Obrigado.
Yeah.
Nada.
Bye.
Bye.
Thank you. Bye.
Okay, so next we have Maxine from SmartHelio. Yeah, Maxine, hi. Welcome.
Hi, hello everyone. Really nice meeting you.
Hello, welcome. So we are here with DDP and we are ready to hear your pitch. You can share your screen and start.
Sure thing. Are you able to see my screen full?
Yeah, we can.
Perfect then. So, hello everyone. I am Maxine. As you can hear from my accent, I am French, so please bear with me. So I'm part of the founding team of SmartHelio, and we are the doctors of solar plants. And our aim is to offer our predictive software in solar industry. We are also proudly a B Corp company. So sustainability is really at core for us for the past 5 years. So what do we mean by predictive analytics? Basically, if you look at this plot, so energy versus time, you can see two curves. The first one is blue. So this is the prediction that you're getting from monitoring systems, SCADA, etc. So how it works, it's only going to be based on threshold. Once you have lost a specific amount of energy, then you're going to have alarms. You won't know why is there underperformance, but you know something is wrong happening. And it's going to take lots of time to fix it. Our aim at SmartHelio is really to identify early signs of such failures so we can predict when they will come and accordingly maximize energy gains. So how we do that is using our software that is based on IV pattern recognition. So this is purely physics. We got incorporated in 2019. So for the past 5 years, we've been working with great clients and partners, namely in Italy, Portugal, Spain, Australia, US, etc. We are also working with Shell, as a matter of fact, for their CNI installations on that same topic. And 2 years ago, we raised more than 8 million euros for our first round. And next year, we're going to open our next round. For our future roadmap, which is super exciting because now we are also working on batteries, energy storage. So in the near future, we'll also move into the energy trading. So concretely, how does it work? So you'll see it's very simple. We only need an API access to your inverter, to your existing system. So no hardware need to be installed. Based on that, we would be able to collect the data that we need to generate any insights automatically. And our aim is really to support your fast decision-making with maximized impact. So whatever installation you have to go, whatever family's home you have to go, you know exactly in advance what you need to do by when, etc. So let me give you like some example of concrete features we can have. So those are coming from different case studies that we did with some of our clients, whether it's from C&I or from B2C. So the first one is real-time waterfall diagram. So what it means, and as you can see, you can have the expected energy versus the actual energy. And this gap, we are automatically going to say what are the root causes of underperformance and what are the losses. For example, here, you can see there's some soiling. How much have I lost due to soiling? And you can also have PV module damage. So this is the first step to really see, okay, what is going on in the plant. The second step is to understand how it's going to keep evolving in the future. For example, soiling. We would know how much soiling losses you would keep having in the future, let's say next month, next 6 months, etc. And accordingly, we would tell you when should you clean based on intervention costs, but also rain events. So you can know even 6 months in advance, okay, I know I have to clean that plant. And the beauty about it is really losses projection that you can do with any types of faults. So accordingly, you can see this on that video, it's modeling. We would know in the future how each plant is going to keep evolving the losses. So accordingly, you can really do some interventions clustering. And okay, in 6 months, I have like this 5 installations that I can do at once. And if we take the example of PV module damage, we would know how it's going to keep evolving. So you can also plan accordingly some repowering strategy. And the last one I want to show you is this Solar GPT. So I think all of us know ChatGPT. So we have developed our own LLM model. So everything is protected within SmartHelio ecosystem. And you can really use it, for example, to know what should be my best strategy to maximize the installation performance. Should I add some batteries? Should I repower, etc.? And this is something you can directly ask to this Solar GPT. So this is some impact that we have created. We have seen that we're able to act 4 times faster with 100% fault detection accuracy for ROI of 6 times, since we're able to, on average, increase the performance by 8%. So thanks a lot. We are super excited to discuss more about how we can work and support EDP's strategy and mission in accelerating energy transition. Thank you.
Thank you, Maxine. Thank you for the presentation. Now let's open for Q&A.
For the Q&A, I also have my colleague, Govinda, who is the CEO of the company. Yes, please, go ahead.
I have one.
Hello, Maxime. Hello. One question. How would you draft a potential pilot for B2C or B2B with us in terms of scope, size, timings? How would you draft it?
I can take the answer. So hi everyone, I'm Govinda, CEO founder of SmartHelio. Lighting is not so great, but still it's me. It's human here, not AI.
Yeah.
Okay. It's very simple for us. We generally take 5 to 10 solar plant, which kind of represents the kind of a portfolio of a client. And also in terms of the sizing, in terms of the complexity, like integration and data, and in terms of the importance. So there will be some plant you really want to give more importance because you had a great PPA. Some plant you're like, man, I can live with that, but okay, I have to still take care because it's a customer relationship. And through that, the pilot project will be planned. Generally, it's for 6 months we have, but it can go for 1 quarter to 2 quarters. And what is important for us to really understand the business case here, because of course we have algorithms for everything, but for the pilot, we need to focus on our KPIs, whether it's O&M optimization, performance enhancement, or you want to restructure certain activities around B2C. I say retail market, this one, more distributed, which comes C&I and let's say residentials.
And where would it be a licensing or a pay-per-use or a flat fee, or how would you invoice an average of your cost for this 6 months trial, or the model for invoicing? What is the business model behind?
So it's generally based on SaaS. What is the usual model we go, and then based on the SaaS, we have different variants because based on the complexity of the solar plant. Our maximum cost on the pilot goes not on the algorithm, because that's the most easy peasy part for us, is the really setting up the whole data collection part and automation part. And depending on the complexity you have, that's where the cost will go up and down on that. But generally it's SaaS for us.
I can go next with a question. Maxime and Govinda, nice to see you again. I'm curious to know a bit more about the storage/trading product that you are developing. So what's the end game for that? Which use cases are you exploring, and what have you developed so far?
So this started 1 year back. So all the clients we are working with, they all having this grid curtailment issues right now, and the storage is coming big time. Of course, US is already big and Europe is catching up. And they wanted us to build storage, solar and storage together. So we got a grant of a couple of millions, a research grant through our partners. And we are building the storage. Now, the end aim is that we want to provide best strategy to our client to dispatch the energy at the end. So again, based on solar and the storage integration part. So in that, we have taken a route of, can I know the health of the system better so that I know the reliability of the system to dispatch energy? So that's one part. And the second part will be that when you do cross trading, so whether you want to do for day ahead market or want to consume yourself, you want to store, what could be the best strategy based on that? So this is going on. Right now, product is with beta users. So we have our clients, we are using with them, trying to understand the problem statement. So that's where, like, I think with clients like EDP, it will be excellent for us to really understand your problem statement, because I know the cross trading is the biggest problem of EDP here because of our previous engagement with EDPs.
Very good. Thank you.
Thank you, Andre.
Can I still ask a question? You mentioned you need to set up data collection. What do you mean by that? Do you need to go there and add some kind of hardware? What is that?
Zhao, thank you for the question. So data collection, we don't have to have any hardware because it should rely completely on your data. So that's the rule we have. We're not going to put any hardware. We'll recommend you that, oh, I cannot just collect it because data quality is bad, but we're not going to do anything. So we'll be still sitting in Switzerland. So that's good. Second part is that all the solar plant, we still need to know metadata, like how it's structured, what is the configuration and all those things. So to create the digital twin of that. So that's one part. Second part is that how are you collecting the data? Is it through inverter basis? Do you have your own software where you have centralized data where we can extract the current and voltages with that? And through that, our engineers have to sit to really understand your data structure and data infrastructure. So this is what I mean by data collection.
Okay.
Thank you, Jean.
So thanks a lot. Thank both of you for being here today and answering our questions. We'll tell you the results in the next few weeks, okay?
Great.
Perfect.
Thank you, everyone.
Muito obrigada. Have a nice day, everyone.
Bye.
Have a nice day. Okay, so next we have Leon from Soltell Systems. Hi, Leon. Welcome.
Hello. Hello, everyone.
Welcome. So we are here with EDP and we're ready to hear your pitch. You can go ahead and share your screen and you have 4 minutes to pitch.
Thank you. So my name is Leon and I'm one of the founders of Soltell. We do industrial IoT automation for measuring PV performance. And essentially this deals with the question whether a PV system performs well and whether we can actually rate its health with a specific figure or number. Why it's important, I will tell you in a few slides. So first of all, conventional PV performance measurement techniques, they either rely on physical sensors on the site or using something like satellite remote sensing. And essentially the question is whether this PV system with this power curve is something good or it's something not. And this is something which can be tested with several technologies. One of them is, for example, manual monitoring, and this is the most common one, but the accuracy is pretty low. Actually, most of the underperformance can be unnoticed. The other one, which is less common, but it's basically good for any facility worldwide, is satellite sensing, but its ability to measure is also limited. And eventually we get to physical sensors, which are good but expensive, and then they can bring you to very high accuracy of performance measurement. So we asked the question whether we can do a very precise performance measurement by not installing something on the side, but by using existing IoT sensors which are already there. And that's essentially is like using a PV cell as an irradiance sensor, essentially. So any PV cell is essentially an irradiance sensor, right? And that's what we developed. So we reach very high accuracy, and the cost is very low because you don't need to install any hardware. And this is the root of our technology. The technology is called sensorless or sensorless weather measurement. This was developed. There is a sound in the background, so from somewhere. So sensorless was developed with the support of an innovation authority with 2 government grants, and we implemented in several solutions. One of those solutions is called SysMap data, and this is the one which we think is most relevant for EDP. We essentially interconnect with solar finance software, SCADA, or energy management, and provide the data on solar performance. So why it's important? So distributed PV, and I'm talking with emphasis on distributed, which is residential, commercial, industrial scale, mostly rooftop. They're pretty hard to measure. So either you need to use this hardware, which is very uncommon, or you need to use something which is less accurate. And notably, about 40% of such facilities underperform to a certain degree. And more importantly, 12% significantly underperform. So with simple techniques, most of this underperformance goes unnoticed. And you can see the histogram of the performance of many facilities which we measure, and quite many of them can be essentially unnoticed. So why it's important? The first implementation which we found was predictive maintenance. So essentially with such ability for predictive analytics of very high accuracy, we can measure, we can pinpoint the exact performance of each facility, and then we can also analyze and give the reason, the cause, whether it's soiling, whether it's a physical malfunction in one of the components, and whether it's something else. The other implementation which we use is essentially using it for optimizing energy management systems. And energy management systems, the more accurate you get, the more revenue you get from them. So we estimate that our solution increases revenue by about 3 to 7% in most of them, especially with varying tariffs. So we are more accurate than, this is the comparison with satellite sensing. We are more accurate with than they are, and we're actually cheaper, and we do provide cause analytics in all of the cases. We comply with the distributed energy resources standard for our APIs and export, and we do need MPPT level data from the facility to analyze it. So we need to know the data from those PV cells to create this theoretical sensor. And the implementation timeline is about 2 to 5 months, at least on our side. This has to be also implemented in the platform which we integrate with. This is our team. We are a team of professionals. We have an a former chief scientist of the Israeli Ministry of Energy on our advisory board, and we have representation in Europe, and we have a partnership in the United States. A few more things. We have a track record of more than 1,000 systems in real time, system years, and mostly industrial scale PV, also commercial, and recently also residential scale. Thank you very much. And I would be happy to receive your questions.
Thank you, Leon. Thank you. Let's go for Q&A.
Hi, Leon. I understood the problem you're trying to solve. You want accurate data without sensors, but I didn't understand how your technology works. How is it different from collecting data from the inverter? What data are you collecting that other technologies do not collect?
So this is the comparison. Essentially, you need to collect the weather data, irradiance and temperature, to analyze the performance. But you either use it in conventional means. You either use a physical weather station, which has a small PV panel which is calibrated and adjusted, and you have a temperature sensor on the back of the panels to measure their temperature. Then you apply a model, okay? And after that, you get a theoretical performance for a specific day. When you compare the actual performance, you could get the performance analysis. So what we do, we actually collect the weather data not from an external sensor, but we calibrate the internal data from the PV facility on the current and voltage level, essentially to serve as a virtual sensor. So just to understand, the irradiance directly affect the current, and the temperature reverse affects the voltage on the DC side.
So basically, you're not collecting any new data. Your algorithm is smarter. Your algorithm is smarter. Is that what you're saying? Okay.
We are utilizing the existing data from PV sensors and inverter sensors, etc.
And how does that, for example, allow you to understand that the given string or panel is malfunctioning?
So first of all, we're applying this mostly to analyze the system level performance. And this, for example, allows you to understand whether there is soiling or anything else, shading, and it allows you to quantify what's the severity of each problem. So for example, if you have leakage in your system, current leakage, so it's very easy to detect with conventional means that system has leakage. Most systems have leakage from plus to minus, but you need to quantify how much it costs you, whether it's 0.1% and you don't need to care about it, or it's 10% and that's a big problem. So in order to measure this technology allows this.
Okay.
Okay. That question? Okay, I think that's it. Thanks a lot, Leon, for your presentation. And yeah, we'll let you know the results in the next few weeks. Okay.
Thank you very much. Goodbye.
Thank you. Bye. Okay, so next we have Rafael from ev.energy. Hi, welcome, Rafael.
Hi, everyone.
Welcome. So we are here with EDP and we are ready to hear your pitch. You have 4 minutes to pitch. Yeah, and I can see your screen, so go ahead.
Perfect. Yeah, thanks for having me, Rafael, founder and CEO of Apollo Green Solutions. And with Energy, we are empowering the energy smart energy management. We're in the middle of the green energy transition. I don't think I need to explain much about it to you guys, right? From weather independent to weather dependent, from centralized to energy production. And we see with that and legacy infrastructure basically many challenges. Energy supply of renewables not matching energy demand, more electrification, more and more devices, complexity being added to the system, charging stations, battery storage. Okay. What we need is to intelligently connect them to basically get the most out of it, to integrate more renewables. And if we look today how the data management is being done, energy data management, and regardless whether it's now on a big scope, utility scale, or on a small scale, within one building, within energy consumers, we see that data is exported in an Excel file from one system to the other. You send information via email, you take documents, you write something on the paper, you get you lose information, you replicate information. This is where we step basically in with our platform. At the moment, it is an AI-based energy management system for commercial buildings. The benefit, is to traditional competitors like Schneider Electric, ABB, and others that we have a quick implementation, utilizing semantic data models that help us to integrate a lot of data within a short period of time. We have advanced analytics capabilities for that, and we are highly cost competitive. We are a solutions provider, right? A pilot customer. If we look on our energy management system, we use our vendor agnostic platform, our software intelligence, and take the appropriate hardware for that building. And within our first pilot in manufacturing side in Greece, smaller one, we are reducing the energy cost by 10%, spotting anomalies, but also reducing the effort to create reports to an extent of data by 40%, 40 hours within every month. And of course, the additional saving of CO2, where we have reduced energy demand. Now, if we look further with the help of the platform, we are enabling various use cases. On one hand side, the energy manager, the tenant, for their smart energy management within that building. But of course, we can go further by aggregating that information, aggregating the insights to which is power plant, but also how technicians facility manage with reporting and proactive remote monitoring and maintenance. We have our first product launched, co-developed with our first pilot customers, installation company with 400 systems in Greece, a hotel chain, but also a pharmaceutical company that is trusting our data management capabilities in 2 years now. And we got recognized by several media and partners, such as Samsung, Forbes, and we have a strong, diverse team. Myself, more with the business side, managing teams, building up teams, and Enric, our brain behind the models, together with some product and operation folks, supported by a large board of advisors on the bottom. I think we're right at the time, and I'm looking forward to questions.
Thank you, Raphael, and thank you for respecting the time. So now let's go for Q&A. Who wants to start?
Yeah, I can start. I didn't understand if there was any additional hardware needed for your solution to work.
Yep. For the solution, we do work with the hardware that is ideally existing, whether it is a smart meter, whether it's a building management system, or any other smart device that is able to send data. If not, we do have the ability to choose out of a pool of hardware, non-inverters, fatigue lamps, for example, or gas pipe measures, to then add them to the solution to make them data available using.
Okay, and what's your business model exactly?
For the software tier, software as a service, license-based approach, for the moment based on the building per year, starting at 1,750 euros, goes up to 2,000 euros, depends on which features the customer wants to see. And then we have one-time cost for the hardware if this is needed. Just to give you a sense, we are at 1,000 euros to track 15 cases, like the main service. And then on top, if someone needs professional services, that is then project-based.
Okay, thank you.
Thanks.
Someone else? Okay, so that was clear. Thank you, Raphael, for your presentation, and we'll get back to you with the results in the next few weeks, okay?
Thank you very much. Yeah, that's a good one.
Thank you. Have a good day. So next we have Hadar from Dustoss. I can let him in. Hi, Hannah. Welcome.
Hello.
Hi, good morning. So we are here with DDP and we are ready to hear your pitch. So you can go ahead, share your screen. And yeah, you have 4 minutes to pitch.
Okay. Can you see?
Yeah, we can.
Okay, so I'm Hadar Sefi. I'm co-founder and CEO of Dustoss. But first, I want you to imagine you are planning a 5 megawatt solar farm in Saudi Arabia. Only you don't have to worry for 10 years of no dust losses concern, no water consuming problems, and no cleaning timing headache. The problem of dust and soil over solar modules can reach up to 40% energy lost, for example, in Middle East and Africa. Fact is, most solar panels are being regularly cleaned. If we could have self-cleaning solar modules, we wouldn't have to worry about maintenance expenses, maintenance headache, and water consuming. This is the issue we're tackling, and this is our solution. It's a self-cleaning solar panel. The thing is, you attached a special cleaning strip to the modules and letting them use the wind as energy. Only the wind causing them to toss away in the wind and clean the surface. In this movie, you can see the difference between solar panels with a system versus solar panel without a system. It all began when they were all cleaned. All these panels were cleaned. And then we attached our system over here. We put here a camera that took one picture each day. And this is how it looks from the camera. Each single second in this movie equals to 5 days in reality. You can see the dust builds up on the right-hand side, while in the middle, the solar module simply stays clean. This is for 4 months. Only we didn't only use 2 solar modules. We use more than 5,000 solar modules, all for paying customers in different places in Israel, different climate areas. So we got a lot of experience. Our technology may look simple. It's not that simple. And also, it's got 6 approved patents already and 7 pending patent families. This is how we measure the efficiency. We install our system on all the panels over here, only leaving a few panels here untouched. And then we measure the efficiency. And you can see that in the year of 2023, at the end of the dry season, we reached 30% more outputs than the panel without a system. And this year, before the rain started, we reached 44% difference between our modules and the modules that were not cleaned. So what is the pilot goals? What I see the pilot goals? First of all, and the most important one, is to get solar manufacturer approved for using this cleaning system and cleaning method. And then we also want to demonstrate and prove the system's efficiency. The pilot method, as I see it, should be target 3 different environmental test sites, install dust on cleaning system on some of the site modules and leave other without the system, and then come back after 1 year and evaluate. The first thing we want to evaluate is the solar modules to see that no damage has done. We can do it with STC test, with X-ray imaging. We want to prove the manufacturer that this system doesn't causing any damage to the solar panels. Then we want to measure the efficiency, and this we can do versus the control panel that we left untouched. And we want to prove the durability of the system. It's not long enough, but we can get the hint of how durable it is. This test will be conducted with the awareness and approval of solar manufacturer, because this is our main goal. So I ask you once more to imagine, and then ask why imagine. If we together, we can make this reality. Thank you.
Thanks for the presentation, Hada, and for respecting the timing. So let's go for Q&A.
Quick question. So this looks really simple, which is great, but you mentioned you have several patents. What are the patents about?
Well, the patents about the method. The most important patent is about the method. You can't use no other material, not any material you can choose because the method is the patent. So this is the main issue. Then we got some more other patents regarding the material, regarding the design, and etc.
So no one else can attach strings to panels because you have a patent?
Yes.
Okay. Where is that patent?
It's well, some of the patents are already approved and some of them are not approved. So the approved patents are in the United States, in India, in Australia, in Israel, and in South Africa. But the next generation patent, which is we have two different ways of cleaning. The first way is to clean along rows. I didn't show it. It's something that still we have problem with. This is already approved. The patents that are under in the national stage right now are the one that you saw in the movie, and this is will be granted, I hope, in the same countries, also in China and also in the United Arab Emirates.
Okay, two very quick questions. Does this void warranties? Is that a problem? And the other one is, what kind of costs does this solution have?
Well, it doesn't void the warranty, but the manufacturer didn't approve this method. So basically, I don't know if something wrong happens with the solar modules. The manufacturer may say it because of this system, because I didn't approve I didn't approve to attach anything to my surface. So what we're afraid is not that our system will cause damage, because we already tested it and we understand it doesn't cause any damage. We just need the attention of the solar manufacturer to say, okay, it was checked and I approve it. And this is the main goal of the pilot. What was the other question you asked?
The costs, because it looks
well,
cheap.
It's
which is great.
The main issue, of course, is labor. How to install this system on the modules. Other than that, it's really cheap. Okay, the main issue is labor. When we tested labor, it was much more efficient than any manual water cleaning of solar panels. So I understand it can be great. Anyway, if we look for the future, I want the manufacturer to sell its modules with a system installed already. So it will be really cheap. It can be really efficient.
Is there any, when you clean, if you would like to include additional cleaning manually manually, like water or something like that, how is the methodology? Is possible to do that, or we remove your system? What happened?
Yeah, well, it is possible to manually clean above the system. You don't need to take it off, and it will not harm the system. More, you can even maintain your system, my system. Once you are already in the field, you can do some maintenance work. It's a good question because I didn't talk about it. We are not 100% clean. I wouldn't eat from the solar surface, but it is very efficient. The estimation we can take off 90% of energy lost. I mean, if you measure how much of energy I could still save, it's only 10% of what is lost. So you may want to do additional cleaning. I think most places you will not need to do additional cleaning.
I'm assuming the efficiency depends on the wind in the location, right? Have you reached any conclusions on which locations are not really appropriate for this? For example, in marine places in Asia, the wind is really low. Would this work there?
Well, wind is one of the things that matters, but it's not it's not the most important thing. Basically, wherever we tested it, also in light wind, it cleans. It may clean a little bit less good. If I talked about 90%, it may be 80%, but it will still clean. The issue is what kind of dust you have. We prefer dry dust. If it's something that's sticky, our system is not good for it. It will not take care of pigeons' drops or some sticky thing from trees.
Right.
Because close to any cement plant, do you have something like that installed or not?
Say again?
Cement plant. Do you have any this system installed close to the place like that?
We tested it once beside a cement plant. It was better than without the system, but it wasn't really good. The cement can stick hard to the solar module, especially while the module is still dry, and then it sticks before our system can remove it. Though it's better than not using it at all.
Yeah, that's good.
One question, Hadar, in terms of maintenance of your attachment, how does it work? What is the requirement?
To maintain my system?
Yes.
Well, you have to work. First of all, we are still, of course, developing. And today we reached a stage where we can leave the strips for 3 years. Under development, we understand we can reach to 10 years, which before looked something that will never be done, but we understand now it can be done. The maintenance will be to come and to see where you're missing maybe a cleaning strip, one strip, or something happened to the strip, so you need to replace the strip. As of for today, you need to do it manually. Of course, if you're looking and if the system will get very wide in the world, automated solution can be done, but we didn't touch it yet.
Okay, so thank you so much, Hadar, for your presentation and for answering the questions. We'll let you know the results in the next few weeks, okay?
Great. Thank you very much.
Thank you. Bye. Okay, so now let's go for a quick break and let's be back in 10 minutes, okay? See you.
Sort it out before you twist it out. Sick and tired of messing around. to me. Money ain't no good to me. Ooh, yeah. Money ain't no good to me. Money ain't no good to me. Ooh, yeah. Hold it down before you breathe it out. Stack it up before you lose your touch. Sick and tired of messing around. Light up a good way to play around. Sick and tired of messing around. Light up a good way to play around. Money ain't no good to me. Money ain't no good to me. Ooh, yeah. Money ain't no good
Hello, is everyone there? Okay. So now we're going to have Lucas and Michal from Solaris Vita. John, you can let them in. Hi, Lucas. I'm Michal. Welcome.
Yeah, hi there.
Hello, welcome. So we are here with EDP and we are ready to hear your pitch. So one of you can go ahead and share your screen and start presenting. You have 4 minutes to pitch.
Okay. All right. So hello, everyone. My name is Michał and we are Solaris Vita. And our mission is to use artificial intelligence to ensure maximum efficiency of PV plants each day. We are a spin-off of 100 developers strong software house, and we spent 2 years with a dedicated R&D team to build Solaris Vita artificial intelligence models before we went to the market. Our DNA is in artificial intelligence building, data science, and photovoltaics. So what problem are we trying to tackle? Virtually all utility scale sites underperform right now. And this is due to anomalies like substring issues or module defects. These defects exist, but owners usually are not aware of them. How come, you may ask? Well, even new sites are handed over by EPCs with hidden defects. And if the site does not have an advanced analytical system, the owner can't really assess whether asset manager or O&M is doing a good job. Additionally, without intelligent diagnostics, technicians make unnecessary site visits, which drives costs, but does not really help with preventative maintenance. We have tested 300 PV sites, and we have found anomalies on every single one of them. How did we do this? We gather data from a variety of sources, from weather data to drone to pictures to devices. What's important is that we require no additional hardware to be installed on site. We connect to the loggers of the devices that are already on site. All of that data is then transferred to our AI models, and the outputs are real-time diagnostics, drone thermal images analysis, digital twin, and forecasting. Let's see that in action. So here's the overview of one's portfolio. First, we connect to around 10 data sources. We let our AI learn the site and calculate the ratios. And the key ratio that we focus on is EPI, Energy Performance Index. This EPI tells you about the performance of the site factoring real-time local weather. So EPI can go up to 100, and whatever is missing to that 100% is due to technical failures and suboptimal maintenance. It's not the weather. For our aerial inspections, we work with third-party partners to gather thermal data with drones. All of these pictures, terabytes of data, are sent to us. And then we apply our AI models to detect anomalies down to the cell level. And we can classify and calculate how much losses they generate. Our main system, PV Copilot, analyzes the situation inverter per inverter real time. Our AI models are great at spotting anomalies that they find there, and are also great at avoiding false positives. And we can even go down to the string level in precision. All happens real time. So how we would like to take this forward? We would like to do two pilots. The first pilot would be an AI analysis of the data from a drone inspection. We would need a 40 megawatt plant somewhere in the southern hemisphere, because we need certain irradiance, and in November, Europe will be off for that, even Portugal. You will get all the anomalies on the site down to the cell level and calculation how much production you're losing. And other than 10K, we don't need any resources from you, and we can do that in a week. The second pilot would relate to our main system, to PV Copilot. Ideally, we would like to analyze your problem sites, but we can do that for any site. So the ideal would be a site that you know is underperforming, but you don't really know why. We need access to the data from all devices. We will calculate EPI and other KPIs. The AI will learn the site for about 1 month. We'll see how it works. and then it will create its digital twin. And when it knows how it works, it will know how it should work and will start providing insights. All right, so I'm excited. I hope that you will join the list of the companies who trusted us. And I'm sure that with EDP, we can set the new standard for renewable energy performance. Thank you.
Thanks a lot, Michal. Thank you. And great timing. So now let's go for Q&A.
Yeah, so let me stop that share. I'm still sharing, right?
Yeah. We can still see your screen.
Okay. Right. Okay, cool. So I'm waiting for questions.
Yeah. Hi, Michal. One question on my, well, two questions on my side. The first one is, which is the minimum size of the plant in order to make it feasible?
Yeah, so generally we don't go less than 1 megawatt. So 1 megawatt, but and we actually did a bunch of these, but generally we like to work with larger sites. But 1 megawatt is the minimum. Yeah.
Okay, so okay, 1 megawatt. Okay, my second question is regarding to the pilot proposal number 1, which is making use of drones data.
Yeah.
I mean, it needs to be taken by you or your suppliers, or we can have already the data on our own and share it with you, and let's see if your algorithm is working for that. I mean, I'm talking about thermography or other techniques.
No. Frankly, I prefer for the site owner to do that. We have a wide network of drone partners in many countries, and we generally don't do that ourselves. But yeah, I mean, what's important is that these pictures are taken in a very rigid specification that we determine, right? So that our AI models can use it. So, but we'll send the specification. For a skillful operator, it's nothing difficult, right? But you need to be taken at a certain height, in a certain pattern, and so on, right? But if we send this specification, by all means, we actually would be ideal if you send us the pictures. Yeah.
Okay, and the data that you're processing is thermography image by drone, is it?
Yes, that's correct. Yes, the first pilot is about that. Yes.
Okay, thank you.
Okay.
Who else has questions?
Yes, I wanted to ask about your past experience. Have you had experience mainly with utility scale plants, or have you also worked with industrial or commercial sites, more DG solutions?
Yeah, so all in all, we did 300 sites, and a number of them were smaller. But for us, smaller means 1 megawatt. We generally don't go below that because of because of cost. To be honest, we can just as easily analyze half a megawatt or smaller. For the AI models, it doesn't really matter. But we see that the greatest benefits is for large sites. And if you have a small site, on a roof, in theory, you can manually actually properly check it. If it's you can send the team and you can do that manually. If you are talking about the site that's it's 100 megawatt, it's, I don't know, a couple 100,000 panels, it's not possible to do it manually well. So that's why we generally target large sites, but actually right now we are in conversation with a very very large retail chain, and they have 2,500 roofs. Yeah. So that will be probably a project that we will do with them, like constant monitoring, but also inspection when they will be sending the pictures. Yeah. So it is possible, but generally, our target, our general target is above 1 megawatt.
Okay. No, I mean, we have roofs that are more than 5 megawatts. So there are many different types of roofs.
Okay, that's perfect then.
Okay. Thank you.
Okay, great. Jorge, do you still need the separate session? Okay, so Michal and Lucas, thank you so much for your presentation. I'm going to ask you, Jorge has some extra questions for you. is it okay if we pass you through another room? The
sure.
three of you?
Sure.
Okay, clarify
please.
those. Okay, thanks a lot. Yeah, thank you.
Thanks.
Thank you.
Bye.
Bye.
Okay. So next we have Matt from Flock Energy. Hi, Matt. Welcome.
Bom dia, Margarita. How are you?
Yeah, I'm doing well, thank you. I hope you're doing too. Yeah.
Yes, good. Obrigado. That's all Portuguese that I know in one minute, less than 1 minute.
Okay, so switch to English. Yeah. Okay, so we are here with EDP and we are ready to hear your pitch. So you can go ahead and share your screen and you have 4 minutes to pitch, okay?
Sure. 1 second. Let me know if you can see everything.
Yes, we can.
Go to the start. Shall I begin, Margarita?
Yeah, go ahead. You have 4 minutes, yeah.
Thank you. Good morning, everyone. My name is Matt. I'm joined by my co-founder, Ankur, and we're here to present Flock Energy. We're building an energy data marketplace business to make smart meter data and genuine energy insight available more simply in real time for everyone. Don't need to explain to you how busy you are deploying many things, among which are smart meters to your residential and commercial customers. Clearly, they're a huge step forward in the modernization of the grid and turning the grid smart. But we reckon there's only so much that you can do with the data that you yourselves are collecting. Globally, we're going to see roughly 800 million smart meters deployed across the rest of the 2020s. Of those, a staggering 250 million will be in India alone, which is the market that we've been in first. The data that's collected by these 800 million smart meters will be roughly equivalent to 500,000 hours every day of Netflix streaming. It's a huge quantity. And this data has all sorts of value, could be really powerful for a whole range of different players in the energy system. Clearly, it's valuable to you for making your own operations and your distribution grids more efficient, to reduce peak load, to reduce grid stress. But we, through our pilots, which we'll come to later on, also know that this data can be really powerful for solar installers, for energy efficient product manufacturers, as well as much more meaningful than is currently generally available to households themselves. What we do is we bridge the gap between this wave of data that utilities are collecting and these different problem statements or use cases who currently maybe struggle to extract maximum value from the data that's available. The way that we do that is with a fourfold process. The first thing is to work with utility partners to ingest and absorb their smart meter data. The second step is to use non-intrusive load monitoring to disaggregate that smart meter data into per appliance consumption. The third step is what we call contextualization. So we take this disaggregated appliance by appliance view of every household and we overlay that with external non-proprietary data sets, be they from weather, from geospatial databases, from property registries, as well as distribution level grid data. And then the fourth step in our value proposition is to propagate the insights generated from this contextualized, disaggregated view to different use cases who would benefit. And the reason that we call this propagation is that through contextualization and disaggregation, we're coming out with 4-dimensional profiles for every single household in a utilities customer base. And these 4-dimensional profiles can be used to make really powerful predictions about what consumers might buy, what activities they might prefer. For instance, Our beachhead market is rooftop solar. We know that you're very interested in distributed solar generation. You may know that in the residential space, conversion rates are almost unfathomably low. Around 1% of all leads convert to a project. So what we do is we take that smart meter data, we disaggregate it, we contextualize it, and we then identify high likelihood candidates for that particular product. And here is a screenshot from our marketplace, from our platform, where we're basically identifying individuals who have a great likelihood of converting to solar, massively improving the process by which our installer customers go through. But that's really just the start. There are all sorts of use cases, some of which you will already be thinking about, many of which some other stakeholders who we're in touch with have already told us about. And what we're doing is bringing all this data together, contextualizing it to make it available to all these different kinds of players. We have 3 pilots covering 250,000 households so far since we started this concept in January. We're piloting with 3 large utilities in India, with 2 more to come in the rest of the year. In terms of how we'd like to work with you, we propose a small-scale pilot around 50,000 residential customers, and we'll do 2 things. We'll do home energy reports for behavior change and improved energy efficiency, and we'll do customer profiling for rooftop solar assessment, flexibility identification, and to identify also vulnerable customers who might need additional support through the winter. Thanks very much.
Thanks for your presentation, Matt. Okay, now let's open for Q&A. Who wants to start?
Yeah, just a quick question. I always ask this one, just to clarify, is there any additional hardware needed to install in the client's residence, or is it really just smart meter data?
Just data.
Smart meter data.
Okay.
So, for example, we're aware of the, I think, ready products that you have available to customers in Portugal, which I think does some of the same job, but requires that additional hardware. That additional hardware is perhaps an obstacle to some people adopting it. What we do is we just need the smart meter data, and from that we can infer the rest.
Okay, thank you. Understood.
A quick question just to understand, or 2 quick questions. Sorry, I'm without video. What are your end clients?
Awesome.
And who are your competitors? Thank you.
So our end client, the paying client, are the likes of solar installers, appliance manufacturers, or financial services institutions who might benefit from access to this really deep consumer data, consumer financial spend, transaction data. And our competitors include many big names who do behavioral energy efficiency programs, the likes of O-Power, now owned by Oracle, Bidgely in the States, some companies like Sense, who are long-standing experts in non-intrusive load monitoring. The key difference for us is that we don't charge utilities. So you wouldn't be our paying client. You'd be our enabler. You'd be our partner. We might even end up providing revenue back to you from people who are accessing data and insight from our platform. And that means that we can get in touch with, integrate with, and indeed partner with utilities much faster than these other players who tend to try and sell their SaaS solutions to the utility, which means going through a more enterprise sales type of approach, which can often take much longer, as well as incurring cost for you. Whereas what we do is provide that value for free and enable much faster access to the data.
Thank you.
Time for a last question.
So the customers you've been working with, what are the use cases they've been working on, and the algorithms that you have? You said that they're very optimized for predicting which customers can buy solar, but do you have other strong use cases your algorithms are strong at?
Ankar, do you want to come in?
So there are 2 primary use cases that utilities in India are interested in. The first one is around theft detection. So theft is a big use case. Roughly 8 to 10% of commercial losses come from theft for Indian utilities. And the second one is home energy needs to be more efficient, or home energy usage needs to be more efficient. That's the second use case that we are trying to help the utilities with, given that utilities are actually losing money because of the subsidized electricity that they are providing to residential customers. So these are the two primary use cases we are targeting on the utility side. Apart from that, solar is the revenue generating use case that we already spoke about.
Okay, thank you.
Okay, we ran out of time, so thank you so much, Matt and Ankur, for being here, and we'll let you know the results in the next few weeks. Okay.
Thank you, everyone.
Yeah.
All the
Thank
best.
you. Okay, so next we have Thomas from ev.energy. Hi, Thomas.
Hello, good morning, everyone.
Welcome. So
Excellent.
we are here with EDP and we are ready to hear your pitch. You can go ahead and share your screen and you have 4 minutes to pitch.
Super. Let's go. Good morning, everyone. Thank you for your time for me to pitch EV Energy. My role at EV Energy is the Business Development Manager for Europe, and in the last 2.5 years, I've been delighted to bring EV Energy's technologies to the Netherlands, Germany, Italy, and most recently, Portugal and Spain. What do EV Energy do? Our mission is to connect everyone to greener, cheaper, and simpler charging. We do that because EVs are a great opportunity, but could also be a great burden for customers. We know that EVs are going to have millions of kilowatt hours of energy needed, which will go to energy companies and distribution operators rather than to gasoline companies. You're all energy experts. I don't need to explain that we want to shift that load to times where they're not high carbon, and that's where we get our greener, cheaper, and simpler. We know we need to capture the hearts and minds of customers to make this work. So for EDP's end customers, your drivers, they don't need to become energy experts. We want them to have simple products that allow them to save money. It's a great motivating factor. So EV Energy's technology will optimize and control the EV, the solar, or the battery, and that'll help you to grow your customer base, keeping them very happy and motivated to keep using your products. We are technology agnostic. We work with all OEMs, all hardware, and then we connect to the grids to allow us to generate revenue from supporting them and delivering it to customers through our energy retail partners. What is our product? Ultimately, you can consider it as 3 modules. Central to this is our algorithm and our virtual power plant, which controls and optimizes those behind the meter assets. We also have over 50 deployments, either through API or our own apps that we deliver to customers. And then with the utility partners, we know data is so important. Our data suite then integrates back into your systems. This helps customers move from dumb charging, which will hurt the grid, up the levels of smart charging from vehicle to grid as our ultimate goal at the end. What values can we unlock from smart charging and flexibility? Well, we see this as 4 different revenue streams. Energy trading, such as we could optimize to the OMI EA price signal the day ahead. Retaining your customer base, reducing your cost of acquisition, launching new tariffs. If we think of Octopus in the UK, where we are based, we have the same technology stack as them, but we are not an energy company. We want to give you the tools to launch products like Octopus have in the UK. Grid services, UK is a leader here. We are generating €10, £10 per month by supporting the grid. And we are already working with Aegeus and Piclo, who are partners that we know of, that we could bring behind the meter flexibility into those customers. And optimizing to home solar is another massive benefit that our technology allows, which customers love. In 10 seconds, I'd like to tell you about ev.energy in the Netherlands, who are one of our partners. They launched a dynamic EV charging tariff, which saves customers massive amounts of money. This is a load curve which shows how we've shifted that load to the cheap hours, and customers are on average saving €5 a month, and 20% of drivers have been paid for a session. Finally, what does that mean for EDP and EV Energy? I would love to pilot this together, unlocking those different value streams in the Portuguese market and interviewing your customers. Understand what they need to move them from dumb charging up those levels and save them money whilst they do it. We hope you can plug into better with us, and I look forward to your questions.
Thanks, Thomas. Thank you for respecting the timing as well. So let's open for Q&A.
Thanks, Tom. Maybe I can go first and maybe follow. So just maybe like to start with two questions. On an average, how much energy per customer have you been able to save in case of UK? Because I know they launched the V2G tariff, but the success rates depends, right? On sort of the location, amount of EV available in the area, and things like that. So can you give a number on that? And I think the second part of the question would be if you can actually shift the load, like what percentage of load have you been successfully able to shift? Like let's say avoiding grid charges and so on.
So the amount of load that we can shift, when we have demand response events, so those grid response events, we're typically achieving 90+% of the EV load is shifted out of the window where the grid operator is asking us to turn down. In terms of the number of people that come on to new EV tariffs, it's quite dependent on our partner and how well they can message it. We can help them build the tariffs, but ultimately the delivery is through your brand. We are not an energy company. We are software and agnostic behind it. With ANWB, we've seen that they captured 200,000 customers within 3 years of launching as a brand new energy company, and smart charging was a big part of that. So we typically see maybe 20% of a customer's user base will immediately want to take up an EV offering, to give you a rough rule of thumb.
Thank you.
Tom, you said that you're working with Aegeus, no? Isn't it?
Yes.
Which team are you working with?
So we're not contracted with Aegeus. We are working with Piclo in many different territories, and we've been at the webinars ready to participate in their constraint management zones.
Okay.
What we don't have so far is enough Portuguese EV drivers to meet the demands of those constraint zones. So we are technically very ready. We're working with Piclo in the UK on very, very similar projects. If we had more customers, maybe from an EDP pilot, we could immediately start testing those flexibility revenues with Aegeus.
Okay, thank you.
Very welcome.
You say one of your revenue streams are from the arbitrage market, right? If I understand correctly. Is that correct?
Yes,
Sorry,
the sound is not so great.
Apologies for that. Sorry. Can you hear me now better?
No, but I think the question was about arbitrage markets.
I don't know, but can you make the question again? Okay, or we take someone else's turn. João, go ahead if you want to.
No, I was just going to tell Arunava to write the question. I can ask a question. It wasn't very, I understand the use cases. It wasn't very clear from a technology standpoint. What are you bringing into the table?
So we are bringing connectivity to the behind the meter assets. So we connect to EVs, wall boxes, solar inverters, and batteries. And then we optimize those in our virtual power plant. So our technology here is the virtual power plant, and the last bit of technology is enabling that customer experience. So we have APIs which you can plug into your apps, your EDP Solar or EDP Charge, to give the smart charging functionality to your customers. Finally, we have a web app and a app in the app stores if you want to just white label that technology. But API is where most companies are moving towards.
When you say connectivity, you mean software level in connectivity, right? You have an APIs for every kind of device, and you integrate everything and provide it at a single point.
Exactly. Yeah. So we connect to the vehicle telematics or the OCPP server of the wall box. It is a software connection. We don't need to put a hardware device in the customer's house.
And do you have limitations regarding the O&Ms, the vehicles you can work with, those kinds of things, or the products you can work with?
We have 90% coverage of most homes because we connect to either the EVSE, the wall box, or the EV. Some OEMs, MG, some of the Chinese brands do not let you connect to their telematics. That is what we are working with them directly to get bilateral connections to make that coverage 100%.
Okay, and about batteries, do you work, for example, with Huawei?
Yes, I can check our full integrations list, but yeah, the technology works for any device as long as we can access.
Thank you. And in regarding the pilot you propose, I understand the pilot will include all the regulation and specific conditions of the Spanish market. In my case, I am based in Spain. I mean, you have the technology, but a pilot will be to understand the market, analyze where we can provide services and the benefits we can deliver to the customers. Or how do you see a pilot in Spain?
So I would recruit a set of customers, and then we will optimize to different signals, which are going to generate EDP the best money or allow EDP to offer a different tariff. So I mentioned OMI as the day ahead market. We can optimize that day ahead market, then prove how much money you have saved from your energy purchase costs because we are optimizing to that market.
Okay, but that is individually for each customer, but not as a virtual power plant, isn't it? I mean, working with the day ahead market is just individual analysis and management. But from the point of view of virtual power plant, that will mean something a little bit more complex in terms that Spanish regulation is not the most advanced one in Europe. And we have the figure of aggregator launching in the first quarter or the second quarter. So the pilot will mean to analyze the Spanish market and extract the value where we can participate managing the assets, something like that? Or do you already have analyzed the Spanish market?
I'm mostly working in Portugal, so I don't know the exact of the Spanish market, but I will follow that up with an email.
Okay, thank you.
The principle is the same.
Sorry to interrupt. We ran out of time. Actually, we passed the time. We have some questions in the chat, but Thomas, after this, we'll send them to you by email. Okay. Okay. Thank you so much, and we'll get back to you with the results in the next few weeks.
Thanks for the extra time and the great questions. Have a great day.
Thank you.
Bye-bye.
Okay, so next we have a funny name, from eMabler AI. Hello. Hi, Live.
Hello.
Hi, welcome.
Thank you.
So we are here with EDP and we're ready to hear your pitch. Go ahead. You can share your screen and you have 4 minutes to pitch.
Yeah. Let's see here. The share.
Yes, we can.
Great. So thank you. So I'm Leif from eMabler, been working in e-mobility since 2008. So sorry if I come across as a little bit arrogant on some of the new on the proactive message here, but we are basically coming with that the APIs are dead and long live the connectors. Now, eMabler, why should you basically listen to us? It's because we are sort of living in the future. In our home market, we have 90% of the car sales are actually EV now, so it's only 3% gasoline cars. And we have more EVs than diesel cars on the roads. So we are starting to see this kind of mass scale adoption of and how to implement into the businesses. So what we are focusing on is not developing what the market needs today, but we are actually, in our view, deploying what we think the customers need tomorrow. And we have some stats there. We have 45,000 charging points, 50,000 MRR, 1.3 million charging sessions, and I think we have about 15 people. So we're quite efficient in terms of punching above our weight. So back to the APIs. That's been our kind of success story since we launched. We have been a very open platform in where the contrast is these silo platforms where you get everything as a white label. We have made everything available as an API. So anything you can do, we can do. And it has been a great success for us. So if we focus in on, for example, an aspect of an ecosystem, the invoicing system and CRM, we can then, through this API strategy, facilitate a completely automated boarding. If you use our APIs, you could kind of connect your CRM and billing system and have a whole journey from contract one to billing the end driver without any manual work. So that's super sweet. The only issue is that it takes time to do it. So freedom comes at a cost. And for typical customer projects where they implement APIs and take EV into their core business, you are looking at this kind of cost structure here, which is around 108,000 to 200,000 euros to make such an integration for that aspect of your business. For some, that might not be a deal breaker or crucial, but the 11 months spent doing it is typically something that will make you kind of lose your edge in the market. So we have looked at this and we say that we are kind of now launching connectors to all these aspects of a typical e-mobility architecture. So most integrations in this aspect here are usually the same, so there's no need to remake them. So we are now launching that you could actually just plug and play these things. So that's how we view it. Instead of spending like lots of big projects on making integrations of e-mobility, you can just get it as a service. And that's the invoicing system and CRM in a couple of minutes. If we have had 5 more minutes, we can talk about the same thing for the smart energy management. This is sort of the golden calf that people are looking to in the industry, that and kind of AI preventive maintenance. And all the platforms, our competitors, are kind of investing heavily into making this in-house. As we view it, as we should rather just connect to the best in class and make ready-made integration so that you can kind of launch your e-mobility business without spending all this time and money getting it to market. Yeah. That's what I had to say about that.
Thank you so much. So now let's go for Q&A. Who wants to start?
What I understood is you're selling connectors as a service, as a way for companies to reduce the development effort. Is that it?
Yeah, I mean, we're basically a charge point management system, and the contrast is that we are like open, and we have ready-made connectors to other systems, so you don't have to spend time and effort doing that. And the completely other way would be to just get a white label solution from some other platform, and you put your logo on it, and you sell an e-mobility service as an energy company, but then you don't get it completely integrated to your energy sales or broadband or whatever kind of extra core business you have. So
how do you price it?
Oh, it's quite affordable. It's like a base license fee. So it's in the hundreds of euros, plus hundreds of euros per business connector system. And then we take a couple of euro cents in per transaction fee. So instead of a fixed socket price, where you risk having charging stations that are not being used, costing you a lot in system costs, in platform costs. We just charge for the successful transactions.
And how compatible are you with multiple charges and multiple types of hardware? How many connectors you have in the, what's your coverage?
Yeah, well, we have basically covered all the charging stations that our customer have had a need to cover. So we have the usual suspects. Let's say that's the core of any kind of charge point management system. You need to be able to control a vast portfolio of charging stations, and you need to kind of facilitate to get the transaction and the consumption placed on the right driver. Then we have a couple of utility sector building platforms that we have integrated for the Nordics, like CGI, working on something called Hansen Utility Cloud. We are launching the Salesforce connector on the App Exchange in a couple of weeks, so you'll be able to just download it if you have Salesforce and then plug it into your system. And then you get like an end-to-end onboarding of the asset management of the chargers, and you get all the consumption in there, and you can pick it up on any Salesforce compatible billing engine from there if you like, or you can get them fed to us directly through a push API, and there's a bunch of opportunities.
Okay, thank you.
There's a question here in the chat, which is, could you share a bit about the smart energy management, technical challenges you have faced and how you solved those? OCPP being used?
Yeah. So we have an OCPP energy management, like load management system at the foundation, both for 1.6 and 2.0.1. We have also implemented proprietary load management systems for popular suppliers like, for example, Easy. And then we have a day-ahead market spot price optimization tool that could be used to kind of control that energy management, load management system. The challenge is, to answer the question, is often that this is sort of a thing that you need to test in real life. You need to have cars to see all the different corner cases of how the different hardware manufacturers have implemented how their vehicles and how the chargers react to load management commands from the outside. So that's kind of the laborers' work of it. And then we see for the future, we are not going to make kind of like demand response flexibility aggregator stuff in our platform. We're going to connect to the likes who actually do that. So we're going to open the whole thing up. So if you, as an energy company, have a deal with some aggregator or some other that kind of commercializes that load somehow, you can just connect to us and do whatever you want with it.
Okay, thank you so much for being here and for your presentation and answering the questions. We ran out of time, so yeah, that's it. And we'll let you know the results in the next few weeks. Okay?
Thank you.
Thank you. Okay. Next, and it's the last presentation before the next break, we're going to have SurplusMap, and we're going to have 4 people. So we're going to have Renier, Luis, Thierry, and Adilkan. Yeah, welcome.
Thank you. Thanks, everyone. Very nice to meet you. Can you see my screen?
Yeah, we can. So we are here with the key and ready for you. You have 4 minutes to pitch, so go ahead.
All right, here goes. So again, pleasure to meet you. I'm Renier. I'm the founder of SurplusMap. We're based in Oslo, Norway. I'm together here with Luis, Adilkan, and Thierry. And a little bit about SurplusMap. Really, it offers the most advanced EV-focused solution to optimize the deployment as well as usage of EV charging infrastructure globally. Specifically, our platform combines map-based software with real-time EV charging market insights, spatial models, and predictive analytics for strategic decision-making. The key problem that we aim to resolve is related to CapEx and OpEx decisions, namely where to invest in new charging stations, CapEx, and how to ensure optimal usage or profitability of these chargers, OpEx. And we need to build a lot of chargers. We need to do it fast. As your team at EDP is building out its own network of chargers, it will need to both make better decisions on where to place new chargers, CapEx, as well as ensuring the optimal usage of its existing charging fleet, OpEx. And those decisions will only become more urgent as your network grows and demand increases. In short, the business logics need to make sense and become future-proof. And I guess, indeed, as you all know at the moment, a lot of the companies that are currently developing and maintaining EV chargers are working with their gut feeling in order to meet required targets and lack the data to support these decisions, creating missed economic opportunities and even worse, financial risks. So how does SurplusMap solve the problem? First, we provide our customers with unique and live market insights on charging utilization to give them the best possible understanding of their micro markets and competitor charging usage over time. And then second, with the usage data and other relevant data at hand, we provide our customers with AI-powered utilization forecasting tools. And this gives them the opportunity really to test their potential sites or the new sites on usage and profitability based on real data. And this will then allow them to forecast demand, model ideal configuration of charges, and even advance their pricing strategies. And all of the data and these forecasting tools are embedded in an intuitive business development workspace based on a map, ideal for team collaboration. So when we look at our competitors, most of them focus on retail analysis with EV charging as an add-on module. And SurplusMap's core focus is EV charging. So with our unique proprietary data on EV charging usage behavior, we have developed advanced and explainable AI forecasting tools within a very scalable and intuitive map-based interface. And as we continually train and tune our AI forecasting tools with new and EV-relevant data sets, we will stay ahead of the pack. This is the most accurate forecasting tool for EV charging. And on top of that, we have direct access to advanced domain expertise right here in Norway, which probably has the highest level of EV adoption in the world. So some quick customer cases. Reitan Retail is one of the largest retail and vehicle energy providers in the Nordics and the Baltics. And SurplusMap is their primary source to help them first prioritize and plan where to build their next charging stations within their large and growing real estate portfolio, supermarkets, for instance. And second, help them establish better pricing strategies to obtain price leadership by using our market insights tools. And then our second case is City of Oslo, a big customer of ours, which is really a global leader in city EV adoption. And Oslo aims to make its entire fleet electric by 2025. And SurplusMap is supporting the city by analyzing the future impact of EV infrastructure on the power grid to help them optimize the rollout and utilization of their charging network. And we're currently mapping both the city's public and non-public charging stations and forecasting usage to help the city achieve a full fleet electrification for all types of vehicles. We have a multidisciplinary team with domain expertise in the field of EV charging, data science team with experience in energy forecasting, and a tech team developing scalable AI products. So yeah, we look forward to answering any of your questions and thanks for your time.
Thank you so much for the presentation. Now let's go for Q&A. Who wants to start?
What kind of information do you need? What kind of information do you need from the utility to integrate these kind of data? Do you need like grid network data and things like that? And how long do you need to come up with such a map? Let's say in case of Oslo that you're doing this project, what's the project timeline look like?
Oh yeah, perfect. So the project timeline is basically until the end of January. So we have done, of course, we have spent a lot of time building our network here, and we have the trust, and we have some already access to some data sources. So given that we have the data sources ready, it can take us maybe 3 or 4 months maximum to get a proof of concept done and ready to be used and test.
Thank you.
Can you clarify? You have that slide with the competition, and you mentioned you have your differentiator is the market insights. What do you mean by market insights? What's the information that you have that your competitors don't?
We basically built we call it a methodology to track usage of chargers across Europe. And with that data, we've developed an AI forecasting model. We combine it with other data sets, open source data sets primarily. And what we're then doing with our customers is embedding their own proprietary, their own private data to increase the accuracy. Yeah, that's the right word. Thanks, Lise. So this is our primary data set, the market usage of chargers.
That's open data that you have access to?
Yeah.
Okay, so you're using open data from multiple regions, and then you're fine-tuning it for specific regions for your customers.
Yeah, I mean, one big advantage being Norway is that we have access to a very specific data set that is actually live, right? So we get live data to everything that we do, and then we kind of consider that's the best quality data, and then we kind of benchmark our trackers with that, so we can always upgrade the quality of the data that we track from the open source. So it's higher quality data and very unique data set that I don't think any other competitor has right now.
Okay.
Okay, there's room for one more question. Okay, so thanks a lot. Thank you for your presentation and for answering our questions. We'll get back to you with the results in the next few weeks.
Sounds good. Thanks everyone for joining. Appreciate this opportunity.
Thank you.
Thank you.
Bye-bye.
Okay. Okay, so let's go for a quick break and let's be back in 8 minutes. Okay? See you.
speak your piece, man, but you make it quick. Why can't we just all run and hide from all of this? 'Cause all my planning, I'ma stay within. Why can't you open up and try to let me in? 'Cause I'm feeling like I'm out of here. Then you come complicate things when I'm doing well. 'Cause it only the finest for you, girl. No, you never used to mind us like before. Oh no, I can't say anything. You're keeping me under wraps. Am I really bad? Like embarrassing that you're keeping me under wraps. Catch me up, trip me over. Can't be warm when you're so cold. I'll be walking on for days, 'cause I know that you'll be home. And now I'm feeling like I'm out of here. Then you come complicate things when I'm doing well. 'Cause it only the finest for you, girl. No, you never used to mind us like before. Oh no, I can't say anything. You're keeping me under wraps. Am I really bad? Like embarrassing that you're keeping me under wraps. Catch again, you'll be home by 10. 'Cause I told you once, but now I'll tell you all again. 'Cause all my planning, I'm the one with singing. Come on, just open up and try to let me in. 'Cause you're keeping me under, you're keeping me on. You're making me violent, you're making me soft. You're making it easy, you're making it hard. I won't let you get.
Hello. Are you there? Can we move on?
Yes.
Okay, so let's call the next startup. It's going to be Miguel presenting from Solaris Vita. Hi, Miguel.
Good morning.
Welcome.
Thank you.
So we are here with EDP and we are ready to hear your pitch. You can go ahead and share your screen and start. You have 4 minutes to pitch.
Okay, thank you. Can you see my screen?
Yeah, we can.
Okay, perfect. Are there any rectangles or something? Because in the test, there was some problem.
It's all right now. Like
It's
this,
perfect.
it's fine. There's only one on top, but it's irrelevant. So feel
Okay.
free, Miguel.
Thank you. So, do you know that just by covering the greenhouses of Almeria with solar panels, we could generate enough electricity for all of Andalusia? Why aren't we doing this? It's because solar panels are opaque and block the light plants need to grow. We're Solaris Vita, a startup focused on integrating semi-transparent photovoltaic panels into greenhouses. Our goal is to produce solar energy in greenhouses without disrupting the crop growth. We've been awarded with several recognitions from renowned institutions such as Santander X, La Nave, Junior. Our organic solar cells allow the light that plants need to pass through it while we are generating electricity with the excess of light. We use the same plastics used in greenhouses, and that leads to low fabrication cost and compatibility with crop growth. We've seen a lot of investment in new ways and new spaces to include solar panels, but with these organic photovoltaic cells, we have a bigger opportunity. Just in Spain, we have more than 73,000 hectares of greenhouses, which opens a market of 36 billion euros. Which is the team that is going to make this possible? I'm Miguel Iglesias, founder of Solaris Vita, industrial engineer and consultant. My colleague Jean Guichard, he's the CFO and head of sales. We have a collaboration agreement with a scientific group who is investigating this technology to make it transparent, and we have a network of mentors that support us strategically. Regarding the competition, our organic solar cells are made out of plastic and are adapted especially for plants, for the integration with greenhouses. So what have we done until this day? We created the first prototype in March, the first proof of concept, and now we are working in the second prototype, a 10 square meter greenhouse where we are going to install these OPVs to test the technology. But in order to get to Almeria, we need to test in a bigger greenhouse and test that the OPVs are really commercial, have a really commercial application. So the pilot we propose is to test these OPVs in an Almeria-style greenhouse at CEIGRAM, the Agronomics University of Madrid. We want to validate the technology in a greenhouse similar to those of our clients, and we are going to install these OPVs, these organic cells, in the roof of the greenhouse. And we are going to periodically analyze the results obtained to see if we have space in the market. The timeline of the project will start at the beginning of March and will be done by November 2025, with a total budget of 24,000 euros, specifically for the modules of OPVs and the analysis center. And regarding the risk assessment, we've identified three main risks. The two first ones are regarding the able to manufacture or experience delays. And we've, so the suppliers is unable to manufacture and experiences delays. We have many different suppliers available, so we can choose among all of them. We've already chosen the biggest one, but we can move to others. And the third risk, if the greenhouse is no longer available, we have contacted with our clients or potential clients, and they are available to host the pilot. So you've seen all the potential we have with these organic photovoltaic cells in the agriculture, in greenhouses, and all the market that we can open together. So now let me ask you, would you like to be part of this project? Thank you very much.
Thank you, Miguel, and right on time.
Thank you.
Okay, now let's go for Q&A.
Yes.
Who wants to start?
Yeah, I can start. Thank you for your presentation, Miguel.
Thank you, Lisa.
Just a question because it was not clear for me. So, you do not own the solar panel solution, or do you? Because you were speaking about suppliers and so on.
Okay, so good question. The technology already exists. The technology is the third generation of solar panels. It's like if I said I'm going to do silicon solar panels. It's a really generic term. So the third generation of solar panels is made out of plastics, and the plastics that are now commercially available block the light that plants need to grow. With our group of scientists, we've been doing our research, so we have new materials that make these organic solar cells transparent for the plants. So the innovation is not in the fabrication of the technology, but in the materials we use to fabricate it, the material.
Okay, so when on your last slide you spoke about other suppliers, when you were showing that risk slide, what are those suppliers for?
The suppliers are to manufacture the organic cells. So we are going to talk. So we are talking with them, and they are going to manufacture with our characteristics.
Okay, I understand.
Okay.
Thank you.
You've not yet. You've worked with those suppliers. Have you manufactured the cells with those characteristics, and have you tested them? What tests have you done?
So the group of scientists we're collaborating with, they have done research in which they were investigating all the materials we have for creating these organic cells, and so which one of these materials are the optimal for plants. So they were carrying out in laboratory, and in laboratory it works. So what we are going to do now is the pilot number 2 that we are going to test in October, November, and we are going to install with our suppliers this technology. And the idea is in March, scale the prototype to a bigger one.
And what are the efficiencies that they are reaching compared to traditional solar?
A traditional solar panel is 20%, 20-25, and this one is between 10 and 15. It depends on the materials you use to manufacture them. The thing is, the manufacturing cost this is really cheap in comparison with solar panels, because they are made out of plastic and they are produced in a production ways, such as the newspaper manufacturing is the same.
This is cheaper than traditional solar panels.
In a bigger scale, yes.
And from what I understood, you will not need to retrofit the greenhouses. You will just attach these solar panels to the existing structures.
That's it. So the potential we have with this technology, we can install it everywhere, but we focused in greenhouses because the structures are already done. The greenhouses are oriented to the sun to capture the maximum light possible, and they have the connections to the grid. So it's just plug in and install to the wires to work.
And you as a company, how are you going to make money? What's your model?
Okay, so we're going to sell these solar cells to the greenhouses, and we are going to create a project for each greenhouse. We need to design specific applications for each greenhouse depending on the orientation and depending on the type of plants they have. So we are going to do the study and design, first of all, of the greenhouse. Then we are going to manufacture the OPVs, the organic cells, and then we're going to install it. In the beginning, we are going to externalize the fabrication of the OPVs, of the organic cells, but in the future, we're planning to create our first factory.
And why do you need EDP?
EDP, we need this money to create the pilot. We need to test before going into Almeria directly. We need to scale the technology. We have tested in laboratory conditions. We've done a small project, and now we are doing a 10 square meter. So EDP would be part of the 200 square meter greenhouse and would test this technology. And thanks to the connection with EDP, we can collaborate together in reaching the market of Almeria.
But further ahead, let's say the pilot works. How do you see the role of EDP?
How do I see? You're a big energetic company with a lot of resources, and in order to get to all the market of Almeria, we need a lot of capital and we need collaboration agreements. So EDP, it's a really good option for us to complete and reach this market.
João, let me just ask a final question because probably we'll have Margarida saying we are out of time. But Miguel, do you have any patent, or will you be going for a patent on your technology?
Good question as well. We have planned patent in the following weeks, in the following months, sorry, in order to protect all this information. So yes, we are going to patent this technology. It's not patented yet because the investigations are. It's like we want to get the product, and once we get the product, we can start the patent process.
Okay, so we ran out of time. Actually, we passed. So Miguel, thank you a lot for your presentation and for answering the questions. We'll tell you the results in the next few weeks.
Thank you all. Have a good day.
Thank you.
See you.
You. Okay, so next we have Natasha from Metris Energy. Hello, Natasha. Welcome.
Hi, everyone. How you doing?
Hi. Very well, thank you. So we are here with EDP and we're ready to hear your pitch. So you can go ahead, share your screen, and you'll have 4 minutes to pitch.
Great. Can you guys see my screen?
Yes, we can.
Perfect. So I'm the CEO and co-founder of Metris. Metris is building the operating system for distributed solar. As we all know, solar deployment has grown at pace. Over the last decade, the amount of solar across Europe has tripled. And we're seeing that pace accelerate even further with a 20% growth year on year. We're seeing a lot of growth, particularly in distributed solar as well. And there's a few reasons for that. The first is there's a huge amount of pressure on businesses to decarbonize, but also financial incentives. The cost of PV has dropped over 60% in the last decade. And in the same period, in the UK at least, the cost of business electricity prices have over doubled. And that creates the perfect opportunity for businesses to adopt on-site solar, be it on CapEx or funded. But asset management of solar has not kept up with the pace of adoption. If you're a PPA fund, you employ 2 billing analysts per 100 megawatts to run billing. But there's also a huge amount of manual processes involved in asset management. It's manual, it's complicated, it's time consuming. You have to pull performance data and irradiance data separately and reconcile that and run a huge amount of calcs to understand the performance of the asset, the health of the asset, and produce a customer invoice. And that really not only reduces the amount of performance and asset health you can get out of that particular asset, it also reduces the revenue realization because billing cycles are kicked out 2 to 3 months on average rather than just a monthly billing cycle like we would expect. I think this slide really kind of elucidates the problem. You have a huge amount of assets and databases that need to be pulled every single month to run processes. So that's energy assets like inverters, but that could also be batteries and EVs, meters, export, generation, consumption, maybe even sub-meters, irradiance, accounting, payments. The list really does go on. And today that's done completely manually by an asset manager. Metris is an API-based platform. We connect into energy devices on site, and that allows us to pull data in real time to automate asset management processes. We also allow permissioned access for all the different stakeholders involved in distributed solar. So that could be the O&M provider, the funder of the project, the tenant, again, reducing the amount of time that asset managers have to go in and not only do a huge amount of manual processing, but also sending out reports manually every single month. To bring what we do to life, this is our platform today. We automate asset management, as I said, by pulling data in real time and then producing a suite of charts and metrics that today would be calculated manually once a month. We pull that in real time, and that can be anything from faults to performance ratio, availability, actual versus forecasted generation. And again, all these sites can have different logins for who owns the site and who needs to look at this data. We also automate billing. So a huge pain point we find with our customers is the billing process because everyone wants to make money from these assets. And again, because we have access to the technical and financial aspects of the project, we can reconcile both those data sources, generate the invoice, and integrate payments for a seamless billing process. We also have a really nice customer portal that allows customers to have insights on their energy usage as well as solar usage, and that makes sustainability really easy. And lastly, I know we're almost at time, but we also make asset management smart. So not only do we roll up each individual site into a portfolio view, but we make smart O&M recommendations because that's really where the performance of these portfolios matters. So not just there's a fault, but how much is that fault actually costing me? And we're moving into using AI to actually predict when these faults are going to occur. And so to wrap up, we make asset management automated, cheap, easy, but also smart. Thanks. Should I stop sharing my screen or did you want to jump in with questions?
So yeah, thanks for the presentation, Natasha. Now let's go for Q&A. If there's a slide that you want to show, it's okay. Yeah, you can reshare it, but let's
go for it.
What the question is. Yeah. Who wants to start?
Hello, Natasha.
Hey.
I have one question. How would you draft a potential pilot project with EDP?
Yeah, so EDP is a huge utility, right? So you'll have lots of different pockets that will touch on this product. So that might be, I know you fund GreenVolt, for example. Perhaps this would be a great opportunity to pilot this PPA asset management product with a GreenVolt portfolio. But I also know that you are funding deployments of solar and helping businesses deploy solar. And we have a monitoring platform that powers that whole O&M asset health aspect. So again, it really depends whether you want it to be kind of EDP's own customers or whether kind of GreenVolt would be also an opportunity.
How would you integrate with backend systems? So do you have an integration with backend systems, and how would that work?
Yeah, so currently, I mean, because it's an API-based platform, we're really flexible to what our customers need. So for example, we've integrated into Xero, Sage, and SAP because some of our customers really want the billing process, the accounting process to be kept the same. So it would be a case, I think, of just doing a bit of discovery work as to what backend systems you'd like us to integrate with.
More questions? No? Okay. So Natasha, thank you so much for your presentation and for being here today. We'll get back with the results in the next few weeks. Okay.
Great.
And
Thanks so much.
Bye. Thank you. Bye. Okay. So now we have Manuel presenting future Voltaics. Hi, Manuel.
Hello, Margarita.
Hi, welcome.
Thank you.
So we are here with EDP. We are ready to hear you. So you can go ahead and share your screen, and you have 4 minutes to pitch.
Okay, thank you. Let's go.
Okay. Yeah, we can.
Okay, thank you for the introduction. I'm Manuel Hinojosa, CEO of Future Voltaics. I'm very glad to having the opportunity of pitching here in the Energy Starter program of EDP. I'm going to present a really innovative vertical photovoltaic system solution for the challenge distributed generation for B2B clients. At Future Voltaics, we have developed Vector, a groundbreaking photovoltaic system which combines the use of vertical east-west bifacial solar panels equipped with special optical reflectors, which are specially designed not only to maximize the energy production of the solar installation, but also to maximize the captured value of the output electricity of the solar installation. The high penetration of solar photovoltaics in electrical grids is shaping the market of electricity. It is very common to see very low prices, even zero or negative prices at midday. This is because there is an oversupply of solar electricity, which in the end causes a drop in the value of conventional solar electricity. We saw here an opportunity to develop an alternative technology, Vector, which is not only capable of producing more energy, but maximizing energy outside peaks and hours in order to make a greater value electricity. Vector has many advantages in comparison with conventional photovoltaic technology. First, we produce more electricity per solar panel. We have a higher capacity factor, which allows to obtain higher yearly energy yield in comparison with traditional technologies. We also reduce the carbon footprint this way. Besides, we have a cost-effective solution. We use a low-cost reflective film, which allows us to have a very competitive leverage cost of energy. And we are able to capture a higher value. In Spain, we have demonstrated a 12% higher capture value in real installations in 2024, and it's a tendency that it's going to increase in the future. So by combining a more competitive LCOE with a higher capture price, we think that Vector ensures an improved return on investment. In May 2024, we finished the installation of a 4-kilowatt pilot plant using Vector. Here I will present some operational KPIs during the first 4 months of operation. Basically, we have increased the energy yield by 31%, the capture value by 12%, and in the end, we increased the revenue for the customer by 48%. Besides, the solar panels we use are smaller than conventionals and have been tested in one wind tunnel up to wind speeds higher than 120 kilometers per hour. So we propose in collaboration with EDP to conduct a higher capacity pilot plant with the latest version of Vector. We can conduct monitoring of the performance of different solar photovoltaic systems in comparison with Vector. In particular, we are thinking on 30 degrees south facing, 10 degrees east-west solar systems, and also the innovative vertical east-west, but without reflectors, being the goals to test the technology, to get external validation, to assess the performance of the new version of Vector, and also collect data and compare technology. By this way, in the end, we can evaluate final results, get EDP insights, and formulate and explore next steps and market opportunities for the future. So thank you for your attention. I will be glad to answer potential questions.
Right on time.
Yeah.
Wow. Okay, let's open for Q&A. Yeah. Who has questions? For Manuel.
Yeah, I can start if you don't mind. Manuel, thank you for your presentation. So you said that the LCOE you can reach like 10 to 45% below the, I assume, the normal solar PV systems. Under which conditions do you reach the 45%? Because for me, I know it's not clear that the OPEX in this system over the years, it's lower than a normal solar PV system. So I'm curious about that information.
Yeah, sure. Here I present the numbers where they come from. We have calculated the case for Madrid because it's the location we are getting actual data, so we feel more confident on that. So basically, it depends on which technology we are comparing with. Here in Spain, it's very popular to install flat east-west installations in rooftops that they have a relative low capacity factor. So by calculating the CapEx and the simulated energy yield with these parameters, we obtain the LCOE, which is pretty higher than with the Vector solution. Here we assume that the OPEX is lower for vertical PV, basically because we do not consider the need to clean the solar panels as we have been so far in the installations that we have been conducting during the last 2-3 years, that the vertical position of solar panels basically avoid soiling the position in solar panels. So we consider that this can reduce the OPEX as well. But the main component comes from the combination of CapEx and higher capacity factor of the vectors and the solution.
Okay, thank
Just a clarification, you don't need to clean the solar panels, but what about the horizontal mirrors that you have? Don't you need to clean those?
Well, the mirrors have a certain inclination, so there is a natural cleaning, let's say, by raining. And then besides, there is a phenomenon that the fact that the soiling deposited in the mirrors also contributes somehow because it scatters light. So it somehow loses its design, its the specular design, but we also obtain light from this scattering of the soiling of the mirrors.
Have you tested that? Have you got
Yeah.
results of that?
Yeah, we have been conducting prototypes during the last 3 years, and we tested to clean the reflectors. And when we do that, we obtain a small increment on the energy yield, but it's very lower that in comparison with traditional fixed yield solar system. And here we have the real data obtained throughout all the 2023 in Madrid, which we demonstrated at 25% higher energy yield than 30 degrees south bifacial systems without cleaning the mirrors, neither the reflectors, neither the solar panels.
Okay, and one last question. When you were showing the table before, you
Yes.
also compared with vertical east-west.
Mhm.
Is that vertical taking into account any type of albedo from
Yeah.
white roof or
Yeah. For these simulations, we include 20% albedo, which is what we have in the rooftop where we are conducting the tests. 20%.
Okay. Thank you.
You're welcome.
Okay, we ran out of time, so thank you so much, Manuel, for your presentation today, and we'll let you know the result in the next few weeks.
Okay, thank you, guys. Have a
Thank
good
you.
day.
Bye. Okay, so next we're going to have Karsten and Amelie from SunOyester. Hi, Karsten. Hi, Amelie.
Hello, how are you doing?
Welcome. Good, good. Hope you're doing well too. So we are here with EVP and we're ready to hear your pitch. You can go ahead and share your screen and you'll have 4 minutes to pitch.
Okay, perfect.
Yeah, we can see it.
And is it also getting large? Do you see it in full size?
No, but I think it works.
Okay, fine. All right, yeah. Thank you to my presentation. My name is Carsten Corino. I'm the founder and CEO of SunOyester Systems. We have altogether 3 innovative products in our portfolio. The first 2 are trackers for mainly heat generation and for electricity generation. And the third product are PV lightweight modules. And I want to concentrate this presentation on the PV lighties. So we have a multifunctional and experienced team, which has already supplied a couple of well-known industrial companies. The problem I want to talk about is that many commercial roofs in Germany, in Europe, and worldwide have load restrictions and have difficulties in carrying additional solar installations. And there's a simple solution for that: PV lightweight modules, which are simply glued to the roofs. By doing that, you can have, instead of 50 kilograms of weight per square meter, 5 kilograms. So roughly a reduction by factor 10. There are two different types of PV lightweight modules. I can show you perhaps here a little bit in the screen. This is a polymer type, only 2 millimeters, but a rough surface and very flexible, a bit too flexible. And here is the first glass type of PV lightweight module with a glass front. So the surface is much smoother, it will stay cleaner. It has the optimum stiffness, and it is also more cost effective. So we are presently the only ones to offer this in Europe. And would suggest that in Lisbon, for example, an amount of 45 kilowatt peak of these PV lighties can generate 65,000 kilowatt hours of electricity per year. And the cost of this generation is only in the range of 3 euro cents, so much cheaper than typical costs of electricity from the grid. We are already in touch with the EDP innovation ecosystem, and very recently they suggested us to look at the building of EDP Renováveis in Porto, and to do a planning for that roof with our lightweight modules. We only received it a few days ago, and our planning engineer is still busy, so we don't have it ready today. But our idea would be to do the planning and fine-tuning together with you during this quarter. Then in the first quarter of 2025, the project could be installed. And the first estimate is that for every 50 kilowatt peak of PV lightweight modules installed, there would be a cash flow of 100,000 euros and savings of 600 tons of CO2 emissions over the lifetime of the project. So we are ready to pilot. Are you too?
Thank you. Thank you, Karsten, for the presentation. So let's go for Q&A.
Hello, Karsten.
Yeah, hello.
No, John, you want to proceed or?
No, you go ahead, John. Perfect.
Okay.
Go ahead.
No, this is just to confirm, that we received your message on the availability of your team. No issues with that. Just let us know when he's back that the simulation can be executed with this site. Otherwise, we need to find a different one, but this one is quite convenient for us because this is EDP facility.
Yeah.
That's it.
Mm-hmm. Okay.
Karsten, you said you are the only providers of this technology in Europe. Do you have an exclusive?
Yeah, we have at the moment a soft exclusivity there, and we are working to improve this technology further. So one first step was to have a multifunctional edge protection of this, because the center of this glass product is really solid. but the edge is mechanically a little bit sensitive. And so this edge protection here, for which we received a utility model, protects not only during installation, it protects also afterwards against hail, for example. It defines the height of the gluing because the glue beds shall always be 3 millimeters high. And moreover, it allows to fix through holes in the edge protection cables in order to complete the strings. So all this gives an additional benefit to the modules. And we also have a patent application in preparation, which adds some additional positive properties to these modules, such as better fire protection, better ultraviolet protection, and better airing on the backside.
Carsten,
So,
but my question,
yeah.
I understand that, but what I'm trying to understand is the PV cells themselves.
Yeah.
Do they have any patent which from someone else, or are they any different from other PV cells out there? And who owns the patent?
Well, the cells used in there are normal silicon cells. And concerning the module as a total, our supplier does not provide of special IP rights. So yeah, we will then be with that patent submitted, the first ones to have IP rights on the glass version of this.
Okay.
So yeah, to put it to make it perhaps clear once again, for the two other trackers, we are the complete manufacturers. For these lightweight modules, we are so far expert users, and we are improving the technology in order to bring it to a new level. But already this is really good and attractive, and we would highly recommend to give them a try.
Can I make a question, the last one, or since we are already run out of time? Yeah, but it's quick. And Carsten, thank you for your presentation. What type of warranties do you offer to these products? Since it's a glued solution,
yeah.
My concern is how will it perform over time when installed in the rooftops?
Yes. Yeah, so I mean, there is the warranty of the company applying the modules. So when we do it, for example, for an industrial company in southern Germany, in Bavaria, over next week, then this is a 5-year warranty. In addition, you have the guarantees of the manufacturers, which are 12 years on the product and 25 years on the performance. And concerning the glue, we are using a very experienced European company, which gives 10 years soft guarantee on the glue. The glue looks like that. There are two types. One is really hard, used in car industry, and the other one is pretty soft and used for many foils on the roof. And after gluing, they shall always have a height of at least 3 millimeters so that the water can flow below and so that there's a minimum airing.
Thank you very much.
Okay, so we ran out of time. Thank you so much, Carsten and Amelie. We'll tell you the results in the next few weeks, okay?
Okay, perfect. Thank you. Bye-bye.
Bye. Okay, So now we have the last startup before the break. We're going to have Shiv presenting active surfaces. Hi, Shiv. Welcome.
Thanks for having us. Good morning.
You're welcome. Good morning. So we are here with EDP and we are ready to hear your pitch. You can go ahead and share your screen and you'll have 4 minutes to pitch.
Perfect. Okay, I'll jump into it. Hello, everyone. I'm Shiv from Active Services, and we are reimagining solar. Solar adoption is limited by soft costs. When you look at the cost of solar in the built environment in the US, it costs roughly $3 a watt for a rooftop. But the module is only a small percentage of that. Most of the cost is beyond the module, soft costs, labor, structural balance of systems. So if we want to lower the cost of install, we need to tackle that 90%. And that is a function of the technology. These things are heavy, they weigh 50 pounds, they require large labor teams to move them around, especially on rooftops, and they have inflexible market applications. And all of that is because the core semiconductor is silicon, and that requires glass rigid packaging to protect it. Uh, this is why people way smarter than me, like folks, like researchers at MIT, have developed a lightweight, flexible technology. And you guys have seen these same pain points in the field with the rigid solar panels, because the current technologies, as seen on the left, increase your costs and slow down installation. And on the right, they create unmet market needs. So if only there was a technology that could be integratable, lightweight, low cost, and additive, and can go anywhere. I'm holding two samples here. Oh, they're being filtered out, but one's on a fabric and one's on a plastic. The idea is that it could be like a solar yoga mat that can be rolled out onto a building with similar performance. This is invented by my co-founder and the team at MIT. And then I met him after working at Exxon and the US DOE. We've built a robust team of people that have scaled technologies from small scale to manufacturing scale, like Jeremiah, and then people that have won Nobel Prizes, like Moonji Wendy. You may be thinking you've heard of flexible solar before. There's a lot of companies that have tried to claim that they can make a solar panel that's flexible and also high performance, but they couldn't win on the only metric that matters, which is cost. The reason they can't do that is because their efficiencies or durabilities were too low. The reason we think we can is because we have the trifecta between a easy to manufacture, low cost manufacturing process, roll to roll slot die coating in atmospheric conditions. We have durable packaging that can withstand harsh environments for over a 10-year lifetime in field. And we have commodity materials that have high performance that's comparable to silicon, over 25% in the lab, with very cheap cost floors. The technology has been proven in the lab at MIT. We've gotten significant support from accelerators. We've raised our first money in over $5 million, and we moved into our own facility to scale up our technology. And over the last year, we went from the small sample that I showed you to an entire roll. And this is coming out of the lab last week. So the goal for the next moving forward is to convert this and actually apply this into the built environment in the roofs, facades, shades, and we think collaborating with EDP would be critical to get there. We're going to start with a 1 kilowatt rooftop pilot of our solar yoga mat. This is small, but it will enable us to demonstrate the cheaper installs, lower soft costs, validate the new applications, and prove the competitive performance. Moving forward, we're going to hope to iterate on the pilot strategy collaboratively during the boot camp in December. And then next year, work on prepping and refining the pilot strategy, figuring out the sourcing materials, figures of merit, and then work towards larger commercial and scale. Together, we can unlock the C&I market. The low load housing market in the US is currently untapped, over 6 billion square feet or 100 gigawatts of buildings that can't handle the weight of solar. Collaborating with EDP will help us support our proof of concept and de-risk installation, whereas the benefit to EDP would be to have the ability to develop new solar products in C&I, dominate this market, and enter adjacent markets you guys are already good at. So increase your TAM and increase your rate of adoption. The ask would be to get your expert advice during the boot camp, target and acquire rooftop demonstration sites, and get your technical guidance to validate our assumptions on labor savings and installation. This program would be catalytic for our growth. That's it. If you have any questions, would love to answer them. Thank you for your time.
Thank you so much, Shiv. Right on time. Let's go for Q&A.
Shiv, do you have any numbers you can share regarding efficiency of the modules, cost, and resulting LCOEs, including installation costs?
Yes. So at lab scale, we're at over 25. I can show you a chart that validates that. This is validated by NREL, which is the US national lab that does a lot of external testing for this stuff. But that is at very coupon scale. At larger scale, we're expecting something in the 18 to 20% range to begin with. We use commodity domestically sourced materials, so there's no boutique chemicals that make this like above $1 a watt. We're expecting our initial COGS at small manufacturing volumes to be in the 50 like sub 50 cents a watt range. And then once you're at gigawatt scale, then you get down to the tens of cents or like 10 cents. So this is a good summary of us versus silicon.
How do you glue the panels? Or what's the process you're assuming will be used?
Yeah, so this isn't something that we're not innovating on. There's been a lot of flexible solar companies that have figured out roofing adhesives with large building material companies like Saint-Gobain and others. We're talking with them as well. So there's industrial grade outdoor adhesive that you can use to stick it on. Yeah, an industrial glue.
And are there any specific challenges regarding the duration and the maintenance of this technology?
Yeah, our lifetime is expected to be 10 years in the field at the early stage of our product, but then we want it to be easy to rip and replace so you can keep the rest of the balance of systems like the inverter and the conduit, and then you can just come in and rip and replace a yoga mat. Whereas today, replacing anything on a balanced system is a pain. In terms of maintenance, it should be easier because like soiling is less of a problem with our technology, and then off-angle performance is better. So anyway, I think O&M will be easier for a flexible technology like this.
Sorry, why do you say that soiling is less of a problem?
Because right now, we were at ADNOC last year talking to Masdar. They're the big utility in Dubai, or big like solar developer, and they were saying that like the glass top layer is causing a lot of particulates to cause soiling, as you know. So then we're saying that our co-founder has some technology on that can go on top of our polymer at the very top that prevents some of the soiling, or is more uh, uh, resistive, I guess, to debris collecting on top of it. And that's part of like what the field test would help us demonstrate to you guys.
Okay, thank you.
Yeah, it's part of the packaging solution that we're innovating on.
Steven, what kind of patents do you have on this technology?
Yeah, these are all licensed from MIT. They're essentially two each. A couple on the manufacturing method, a couple on the packaging that enable both the thing that I'm mentioning, as well as sequestration barriers for lead, and then there's stuff on the material stack, so the specific materials that we use.
Let me ask you something. When is the earliest that you can actually pilot your technology? From your slides, I was seeing end of 2025. Assuming that we have a site to test these right away, what would be the earliest that you could actually test these?
We're gonna put something at a very small scale outside in like 2 months here in Boston. So then, at that point, it's just how quickly can we develop larger modules and give it to you guys. I think that's gonna happen in the span of 9 months.
Okay, very good.
But right now, what would you need from EDP to move forward?
What do I need from EDP to move forward? Support during, I mean, I think there's three different things. One is support during the boot camp on what a potential pilot would look like, and that could involve helping us acquire like a demonstration site, or even just understanding like what are the figures of merit that you guys want to see validated. And then I'll also help us validate all of our assumptions on labor saving, installation process, how you engage with EPCs, how you engage with permitting, all of that. Because just getting the technology and manufacturing it is one thing, but applying it in the world, you guys are better at than we are.
Okay. Thank you.
Okay, so thank you so much. Shiv and Dusty for being here today, and we'll let you know the results in the next few weeks.
Awesome. Thank you, everyone, for the time. It was a pleasure to meet you all. Wish you the best.
Thank you.
Thank you.
Same. Okay, so now let's go for a short break. It's the last round. So let's be back in 7 minutes, okay? See you in a bit.
Give me then a pupil and bora toda na tele long taba. La de la pupil and bora dois com três pés. Mais vez, tanto vez. Pra Maria que nasce e que torna renasce. Mundo flama nasce pra deixa um quebra a distância. Quebra a distância. Banhas vas cama na boa e bucocha pira de meu. Pu saliva na minha pé. O manga na pupoca. Esse quem gosta de boa. Forte gosta de boa. Amor não gosta de mas eu mais fundo se creu fundia na mi. Pago nasce de mim. Com dois com três pés. Mais vez, tanto vez. Pra Maria que nasce e quem torna renasce. Mundo flama nasce pra deixa taja pra casar. Taja pra casar. Pra máquina ser menos, se já não pode ser mais. A voz já pode comer. Se mas já não pode cupor.
Hello. Are you back?
Yes.
Okay, so I'm going to call the next startup. I'm going to call Christina from EpiSensor. Well, you can let her in. Hi, Christina. Welcome. Christina, I can't hear you. I see your screen, but I can't hear you. You unmute yourself.
Christina, please write us in the chat if you're having any troubles. She can't unmute. I think I know what's going on. Let me take her back to the main room. Sorry, Margarita. She must be using a Zoom through the browser, probably. Another one of those glitches. 1 second. So Margarita, we're trying to figure out the problem. She is using the app, so it's not that. So we're taking a few more minutes. We can try again, maybe. Just move her again. Let's see.
Let's see.
Okay, so she's
Okay, it seems like
here
it's
again.
Yeah, it's very.
Okay.
Hi, Christina.
Hi.
Great.
Hi, everyone. Sorry about that. For some reason, I couldn't unmute myself.
No worries.
Right, I'm going to share my screen quickly so we don't lose any more time.
Okay, thank you. I can't see it yet. Okay, yeah, we can see it. Go ahead, you have 4 minutes to pitch.
Thanks, William. So I'm Christina Coffey, the strategy officer at EpiSensor, where we're building the IoT infrastructure for the sustainable energy transition. We are all aware of the challenges that we're currently facing. A lot of renewable energy is added to the grid, and that this is growing even faster than predicted. At the same time, demand is increasing rapidly with the electrification of heat and transport and data centers. And this adds a lot of pressure to the grid and for the grid operators. At EpiSensor, we believe that this is a communication problem that needs to be solved. So in the future, we believe that everything will be connected. A lot of energy assets will end up having to be connected and aware of circumstances on the grid. And they need a reliable, rugged, scalable, accurate, and secure IoT infrastructure in order to do this, but something that's designed to deliver energy services fast. And fast is the key word there. If you're looking at the market at the moment, the traditional control and automation systems have set a very high standard for reliability, security, accuracy, and so on. However, they're really hard to implement. They require specialized engineering expertise, and they're very complex as well. On the other side, you have consumer products which are not very accurate and are unsuitable for industrial and commercial environments. So where we sit in is in the middle. We combine the qualities of traditional control and automation systems with the ease of use of consumer systems without the risk and cost of proprietary solutions. So we've been around for 16 years, and we have experience in this space for over 50 years. And we've been trusted to deliver some of the largest scope and most complex energy projects out there by partners like NLX. And I'm going to go into a little bit of detail on these two projects in a minute. But before that, just to give you an idea of the system architecture. So the solution that we have is a demand response controller who is monitoring current, voltage, and frequency on the grid, and it's able to react in under 80 milliseconds to frequency fluctuations on the grid, and control a UPS or battery or generator or any type of energy asset, HVAC unit, EV charger, etc. So this is able to provide both static and dynamic frequency response. Everything is controlled at the ZDR level, recorded, and then that data is being sent over to the gateway, which in turn communicates with your IoT cloud. So you can talk to the TSO or DSO as well. The type of projects that we've been working on, this is a Microsoft data center implementation in collaboration with NLX, where we're enrolling 40 megawatts of UPS in dynamic frequency response. This shows the security and the reliability of our solution, as it's been through due diligence with Microsoft engineers themselves. At the same time, we're also connecting 2,500 battery charging stations in Taiwan into a virtual power plant. This project is, again, in collaboration with NLX. These battery charging stations are spread across the island of Taiwan, and this project has been installed and commissioned within 6 weeks by local electricians that we've never trained and never spoken to. So that's how fast energy services can be implemented. One last project that we have to show is with ESB, where we're mapping the energy produced by a wind turbine to an energy consumed by a Dell data center using tokenization and blockchain technology. So these are the projects, the types of projects that we'd like to pilot with you as well.
Thank you so much, Christina, for the presentation. So now let's go for Q&A. Who wants to start?
Everything must be clear.
When people are shy.
Hello, Christina. One question here. Yeah, one question regarding to the regulation applying your product. Do you foresee any changes or different conditions for regulation in European market when compared to APAC?
Yeah, definitely. There's always differences in regulations in European markets as well as APAC. And one of the things that we're doing really well is over-the-air updates and being able to customize our technology. So, for example, the project in Taiwan, it was one of the very first projects that was launched when the frequency market was opened in Taiwan. And over the course of the first year from the launch, we ended up having to send over 15 over-the-air updates to all 2,500 systems because of the change in regulation from the TSO in Taiwan, as they were adapting and trying to figure out what their needs are.
Okay. So for Europe expansion, would it go through CE marking or product development marking or international standards or something like that? I mean, have you been exploring that, or this is not yet?
Yeah, so at the moment we have projects in the European markets as well. We're in Ireland, in UK. We're looking at Spain as well now, and Portugal with our partners as well. We're pretty much going where our partners are going, and we're trying to build a product that it's applicable to all the markets. So when the requirements are getting more stringent in a market, then we're updating our products to hold to the most stringent requirements as well.
Okay, that's great. Thank you.
Yeah.
Christina, one question. I was trying to understand where to start. So in your mind, what would be the most suitable use case that allows us to get to know the technology, and what would be required from our end? Do we need to identify a set of customers, a set of assets in which we could integrate them in your platform? Then we would manage, let's say, the demand side flexibility and try to understand how to use that in the market. How would you see these starting?
Yeah, so at the moment we've been controlling UPSs as well as batteries, and we're looking at EV chargers next as well. So ideally, the way it would start is if you have any assets that are ready for flexibility that don't have control capabilities right now, that's where we would start. We can integrate with those assets and connect them to the grid and facilitate their participation in flexibility services or flexibility programs.
Okay.
Does that answer your question?
Yeah, no, yeah, it answers. I was thinking how to do it, but yeah, it's clear. Got it.
Brilliant.
Okay, great. So we ran out of time. Christina, thank you so much for your presentation and for being here today. We'll let you know the results in the next few weeks. Okay.
Brilliant. Thanks a million. Bye.
Thank you. Bye. Okay, so next we have Chris from HeyCharge. Hi, Chris. Welcome.
Hi there. Oh, there are a lot of people here.
Yes. So we are here with EDP and we are ready to hear your pitch. So you can go ahead, share your screen, and you have 4 minutes to pitch.
Alrighty. 1 second.
Mhm.
All right. This is going to be a super, super compressed pitch because 4 minutes is so little and we have so much to discuss. But hi, I'm Chris Carday, the founder and CEO of HeyCharge. We are located here in Munich, Germany. And we're making EV charging reliable, cost a whole heck of a lot less, and more secure. And just to kind of drill into what are those problems, we see problems with connectivity to chargers, both on the app side and the user side, the charger side, resulting in reliability. We see cost challenges with installation and operation of the infrastructure, and we see security challenges with RFID cards. This led us to our headline technology. We call it Secure Charge, and it basically replaces the internet connection at the charger and the internet connection on the user's mobile app with direct communication to the charger over Bluetooth. But our patent gives us end-to-end security from the cloud. So we built a whole platform around this. I mean, way too much to talk about here, but basically first-party chargers, third-party HDK, so you can build your own chargers. We've got a retrofit product that will translate an OCPP charger to our platform. We have both white label and turnkey software options, so we can really provide our technology to almost any use case, any customer in the EV charging space. I want to just call out that we do load management over Zigbee, and we have a gateway that can connect to on-premise energy management solutions. Real fast, we are operating here in Germany, selling our charging solutions to real estate asset managers. And it's going really, really well. We've closed some massive exclusive partnerships, including the largest housing operator in Germany. So that tells you it works and it gives us a really advantageous value in terms of cost and product. And we have basically now the plan to sell this to charging operators globally. I just want to call out, we actually have 2 utilities on this slide, both in the United States, one in California, one in Florida. But what's our pilot proposal? We actually have 2. Basically, we have a proposition for multifamily housing. We can do really high-scale AC charging. Really the sweet spot for us is solving connectivity problems underground, as well as fixing the unit economics for very large-scale AC charger deployments. So if this is interesting, we suggest let's pick some pilot buildings and either do a pilot on our turnkey software, or if your app and backend development teams are willing, we can actually do a white label integration. The other proposal is we have basically a retrofit device that is really a good fit for DC fast chargers. Here, our proposition is less about cost and more about security, but in both cases, we improve reliability, uptime, and availability. So we could actually choose, and here we just recommend, the number can be anything, but we recommend 20 to 40 pilot sites where we can install our retrofit device. I want to call out this retrofit device combines both online, basically the original OCPP connection to the cloud with access from your EMSP app. So that's how we're addressing the reliability piece. And just to make it explicit, the fraud piece that we can improve here is that we allow you to actually have the works anywhere advantage of an RFID card without the security problems of RFID cards, which is that they can be very easily copied. Those are our 2 pilot proposals. Basically, call to action here is, it depends on the proposition, but basically in both cases, we just need to validate the needs from your business units. So for multifamily and workplace, do you have a problem with unit economics? Would you like it to cost less? And would you like it to work more reliably underground? On the fast charging side, do you have a challenge with uptime metrics, both from the customer side and any kind of regulatory metric goal that you need to meet? And is there an interest in eliminating the potential for fraud in terms of RFID cards? I'd say that's kind of the foundational step from both sides, is to see if there's actually a problem that we can help you solve with either of these pilot proposals. I promise you this was lightning round. That's actually all I wanted to say. I'm not sure. I actually can't see the timer, but I'm guessing I'm probably almost out of time.
It was this noise, so you were right on time.
Okay, amazing.
Yeah, wow.
That's luck because I literally couldn't see it.
Yeah, perfect timing. Okay, so now let's go for Q&A.
We have this challenge that we have a lot of condos, and we like usually we have a lack of connectivity underground because all the parking lots are like under the ground. How would you see this situation in Lisbon? Like, how could you take approach with your solution?
I mean, the good news is that's exactly the problem that we saw that inspired us to build this technology. And actually, as I mentioned, we are operating directly into buildings like this in Germany. So it kind of we took our technology and platform and we took on the CPO, the operator role, as a lighthouse business exactly to multi-user sites, basically here in Germany, offices, mixed use, and pure residential through real estate asset managers. So this is our channel to the customer, but actually you as a utility are a much more natural channel to these customers. This is where kind of the first stop most people think of to ask for a solution is to ask their energy utility. So we basically built our platform to manage chargers and provide a site level management to a property owner or property operator. We have actually really nice and complex abilities to do things like manage groups of chargers that are assigned to companies on a multi-user site. So for example, we can manage groups of employees who all have access to company provided chargers. We can split, for example, the employee pays for power, the company pays the fixed fees for the charger. We can mix that with both companies and individuals in a mixed use building. The point is we actually typically see a 40% cost reduction in high scale, high volume AC charger deployments, specifically because we can make a cheaper charger. We can dramatically reduce the labor complexity, training requirement, and number of hours. Of course, the fact that it works means you're spending less on support, and of course, the kind of the opportunity cost on the brand when you have a solution that has challenges underground. So I hope I convinced you. We're really actually super serious about the multifamily case. That's the bread and butter of our business, and that's where most of our revenue is right now.
Yeah. Thank you very much.
You're welcome.
Who's next?
Hey, Chris, one more question on our side. What would you say that in terms of escalation of your proposal, what would you say is the bottleneck currently at HeyCharge? What are you seeking for next year, the company milestone?
Well, I mean, our bottleneck is as a young capital constrained tech company trying to run an operations business, right? And this is actually also exactly where we see utilities being very well positioned because you have operational workforce, you've got access to capital. So you could take our technology and scale it way faster just due to your operational capacity, access to capital, and also because you're a trusted brand for energy. We, of course, we're coming in as a new entrant and we have to convince people. So for all of those reasons, our global scale strategy is as a technology platform with operators such as EDP as a customer. We want to make your product, your proposition better. Our core DNA, I mean, I come from Google. My background is in developing technology and maintaining, technology platforms. That's really where we want to be is supporting customers such as yourself in operating in your respective markets.
Do you have any business case in Spain or Iberia?
We have, if the question is if we have actual business, we do not yet. We've had a number of discussions with utilities that have footprints in the area. We have not yet gotten to a pilot. So we're actually super aware that the technology really fits the urban design that we'll find there. So I think the opportunity is epic. We're just really excited to find a utility that would like to go to pilot.
Thank you.
Okay, so we ran out of time. Thank you so much, Chris, for your presentation and for answering the questions. We'll get back with the results in the next few weeks, okay?
We really appreciate it. Thank you all for the time.
Thank you.
Bye.
Bye. Okay, so Next, we have Nicola and Siqueira from PV Operation. Hi, Nicola. Hi, Siqueira. Welcome.
Hello. How are you?
Hi.
Hello.
So we are here with EDP and ready to hear your pitch. So you can go ahead and share your screen, and you have 4 minutes to pitch.
All right. Just a moment.
Yeah, we can see it.
Can you see it full screen now?
Yes.
Okay. So, hello everyone. I'm glad to be here. So, our motto is intelligence to optimize solar generation. We are PV operation. We're speaking now from our headquarters at Florianópolis, south of Brazil. We're 4 founders, 2 business managers, and 2 electrical engineers that have teamed up in 2019. We deliver intelligent monitoring, automation, and predictive operation solutions to improve O&M of distributed solar plants, reducing costs, improve efficiency, and we're committed to reduce costs and speed up O&M performance of solar generation. So the challenge of solar generation, as you might know, it's not easy to perform. So we deal with high costs and complexity in the installation and during the O&M of the solar plants, during the time it's gonna be running. There's lack of real-time visibility and delays in resolving issues, inefficient O&M leading to downtime, loss of revenue. And the current approaches are manual inspections, reactive maintenance causing delays and increased operational expenses. So we have deep knowledge in solar PV and software design. We have been working with solar PV for almost 12 years now. So we are one of the first people that have worked with solar PV in Brazil, and we are glad to do that. So we are software plus remote operation to increase efficiency. We offer plug and play comprehensive and user-friendly solutions through remote operation powered by AI, cloud-based SAS, SCADA system, data monitoring software, and another platform of asset management. So we have now in our platform more than 53,000 power plants from 1.5 kilowatt peak to 6.5 megawatt peak. So summing up, more than 2.5 gigawatt peak in our platform. It's around 7% of Brazilian DG market. Our value proposition, it's a energy data management platform. So we can process all the data from the bills, from the energy bills, from the substation relays. We have inventory control. We can open tickets from maintenance, all with high level performance-based software. Our core business is this SCADA system, totally integrated with possibility to control it remotely. Our AI has been developed through a 2-year program with innovation agency from Switzerland. Our product, it's like this. We integrate all the hardware and software. What we propose are digital twins. So we're gonna make a power plant in our platform based in AI predictive. we're gonna be real-time insights and analytics through predictive operation and automation, and the outcome is gonna be up to 3% reduction in generation losses and improve efficiency in OEM performance. So PV Operation is ready to partner with EDP, delivering cutting-edge solutions in automation of PV plants, digital twins, and predictive O&M to reduce costs and speed up the performance of solar generation. Thank you.
Thanks a lot, Sikara. Thank you. Let's go for Q&A.
Okay.
Let's just wait to see who has questions.
Hello, Sikera.
Hello.
Thank you for your presentation. A couple of questions on our side. So where do you see the real value of your asset management platform, for utility scale or for distributed energy assets? And I mean, it is obvious that there is a fit with utility scale, but here we're talking also about the distributed assets, like I don't know, 1 mega, 2 megas maximum. Do you see also value for application in this field?
Well, I might not have been so clear, but 90% of the plants in our platform are DG, like rooftop solutions and small commercial, CNI. So we have also DG plants from 1 megawatt to 6 megawatts, but the quantity, the amount of plants that are mainly rooftop and small DG.
I also have a question. So, what do you see are your biggest competitors in this space?
Sure. So we have competitors, international competitors like Media Control from Germany, that we have gained some space from some market share from Media Control in Brazil. Or we have Ellipse, that is a well-known SCADA system in Brazil. Delphos, that was already invested by EDP, but the main difference that we go straight from the hardwares. We collect the data from the hardwares, where SCADA from level 1 to level 3. So we collect data from the hardwares and go processing, and we do all the reports like performance ratio report, energy performance index, and all these complex reports for executive level presentations.
Okay, thank you.
Okay.
Time for one last question. Someone wants to jump in?
So one more question here regarding to the projects and the track record executed so far. Most of them have been executed in Brazil or also abroad?
No, only Brazil.
Only Brazil.
Yeah,
Okay.
because Brazil market's so big that we could do anywhere else, and we're planning to do that next year. But first, we're dealing with high demand here in Brazil.
That's great. So you will be meeting our colleagues Friday. Thank you.
Okay, thank you. Yeah, that's it.
Okay, so thank you so much for your time, Sikara and Nicola. We'll get back to you with the results in the next few weeks.
Okay. Thank you all.
Okay.
Have a good day.
Thank you.
Thank you for the
Great day.
Thank you. Bye.
Bye-bye.
Bye-bye.
Okay, so last 3 startups. So next we have Simon and Christian from Latimer Controls. Hi, Simon. Hi, Christian.
Hello.
Welcome.
Thank you.
Hello, great to meet you.
Hi, nice to meet you as well. So we are here with EDP and we're ready to hear your pitch. You can go ahead and share your screen and you have 4 minutes to pitch.
Fantastic. Thank you. Everyone see this all right?
Yeah.
Awesome. Well, hello, everyone. My name is Tristan Liu. I'm a co-founder at Latimer Controls, where we are building and deploying flexible control solutions for standalone solar plants. And I'm joined today by Simon, who's our co-founder and CEO. So we address the problem of solar intermittency due to partial shading. Cloud coverage causes solar assets to be curtailed when power is too unstable to manage. Curtailment is rising annually, with grid operators in California and Texas curtailing up to 10% of solar generation last year. In addition, interconnection queues across the US are in gridlock. These backlogs can reach up to 7 years and are largely due to the grid upgrades needed to handle solar's intermittency. These problems are symptoms actually of a larger issue, as solar today is still not seen as a reliable or flexible grid asset. So let's look at solar curtailment response today. On the left is a day of solar generation with conventional controls. The dotted line here is the grid curtailment, and the red line represents the plant output. So conventional controls average curtailment signals across inverters, ignoring shading and movement, and this leads to under-export and difficulty reporting potential losses for compensation. On the other hand, Latimer Controls optimizes inverter set points to manage cloud intermittency. This maximizes generation and meets set points accurately, even our curtailment signals. We also provide real-time site potential reporting to improve renewable dispatch. So how does it work operationally? When curtailment happens, a set point signal is sent from the grid operator to the plant via SCADA, boom, typically updated every 4 to 6 seconds. Latimer Controls interprets inverter data for real-time performance, optimizing set points to better manage cloud coverage and meet curtailment targets. The FSMS integrates agnostically with power plant controllers and provides accurate headroom estimates to help grid operators with dispatching and stability. And we are currently working to ensure compatibility with other PPC vendors as well. The FSMS further interprets this inverter data to manage dynamic cloud coverage, optimally allocating set points to inverters to best meet curtailment targets. It also provides highly accurate calculations of the plant's potential generation during curtailment, and this unique solution helps grid operators reliably dispatch the plant for stability, which ranges from ramping control or even supporting voltage and frequency support. So our key innovations here is a proprietary machine learning model, which calculates PHL, otherwise known as headroom, with over 97% accuracy using voltage, current, and power data. This is even when a plant is shaded. And this data allows us to intelligently allocate set points, dynamically managing intermittency in real time. And a great example of this is Kauai Island Utility, who was already controlling their solar when we spoke to them, and they wanted to improve their methods. So we worked with them and conducted a study, concluding that their control strategy, which is using uniform distribution of inverter set points, could be improved through our PHL-based control to reduce curtailment by up to 25%. We are now working with KIUC to optimize their curtailment systems on the island's 2 largest solar plants. For our proposal with EDP, we propose a phased partnership and product rollout to achieve curtailment savings across their whole solar fleet, positioning EDP as a leader in solar flexibility and interconnection innovation. This pilot would start with a year-long demonstration of managing the power output of a megawatt-scale solar plant, addressing cybersecurity concerns and system compatibility concerns along the way. We would then expand to a multi-plant deployment, offering the solution in maturing US energy markets. By this phase, we plan to introduce additional solar control features for reactive power and grid services, which would open up some new revenue streams. As EDP's solar portfolio grows, we aim to provide rapid deployment tools, helping them become a leader in flexible interconnection with prioritized fast tracking solar bidding through the US. This would reduce costs and speed up installations for EDP. Now, our team consists of myself, Zach, Simon, and Des. We are spinning out NREL graduate research to make an impact in solar. I'm joined today by Simon, and we look forward to addressing EDP's market needs further in the Q&A. So thank you so much.
Thanks a lot, Tristan. Thank you for the presentation. So now let's go for Q&A.
Yeah, I have a question. How exactly do you do the curtailment mitigation? Is it fully automatic, or do you have to actively control the system to get the best performance?
Yeah, so the controls sit on site and they're fully automated controls. They would live within the power plant controller. What starts the curtailment is some sort of signal that cues the curtailment. So in a lot of our customers and pilots that we're working on right now, it's an AGC signal that comes from a utility operator. That can also, on the distribution side, it could be in the form of a DERM signal, but some sort of set point to the power plant that would receive in the power plant controller. We will intercept and then optimize and execute accordingly with cloud coverage and other scenarios that are causing additional instabilities on site.
Right. And for shading, it's the same thing. So on a non-curtailment scenario, you can also manage shading automatically.
Yeah, that's right. And we're a software-only solution. So if the power plant is completely shaded or the set point curtailment is above the potential availability at the site, we're not going to be able to generate additional energy. But in that curtailment scenario, you saw in that figure that Tristan had pulled up where you have the potential at the site, but due to non-reallocation of set points in the inverters, you are still under generating from that curtailment set point. So we allow you to maximize your generation during the curtailment. And the long-term vision for this would be, allowing solar to become a dispatchable, flexible resource that could be used as a peaker plant or as a grid stabilizing asset, either through pre-curtailment or just in the scenario of curtailment instead of offboarding to peaker plants, being able to dispatch the solar itself.
Right. And last question from my side. How many megawatts do you have under operation?
Right now, 24 megawatts, and that's on 2 sites in Kauai Island Utility Cooperative. And then we have, I think, about another 140, 150 more in our pilot pipeline that haven't gone live yet.
Right. Thank you.
Hi there. Thank you very much for your pitch. What is the minimum size of a park where your solution would be applied, or minimum recommended size, at least?
Yep. So we consider ourselves megawatt scale. So anything over 1 megawatt we would bring value to. But it's definitely important to emphasize that the bigger the better. The bigger the solar plant, the more variability comes with these partial shading events. So 1 megawatt is the very smallest that we would do, but typically some of our demonstrations have been on the small scale have been anywhere from 5 to 12 megawatts, and then our largest is about 100.
Okay, thank you. And you mentioned in the pilot proposal, you mentioned the ideal locations would be California or ERCOT markets. Would this be would you be open to do it in other geographies as well besides the US?
Yes, absolutely. I think part of the reason why we chose those 2 locations is because of their new frameworks that they're releasing now for flexible interconnection. In California specifically, this has to do with what's called limited generation profiles, where distributed solar for the first time can actually follow a load shape. If we see opportunities elsewhere outside of the US or where be it, we would love to pursue that opportunity. I think we have a really good understanding of the US market, and for that reason, kind of chose that as our benchmark.
Thank you very much.
2 very quick questions. Is this control made at the panel level or at the string level?
The control mechanism is in the power plant controller. So it's a single box that goes on site. All utility scale solar sites already have it. And then the set points are sent to the inverters. So you can think of it as being, the strings that congregate at the inverters. So typically a solar site at this scale has, anywhere from 20 to 30 inverters. So that's 20 to 30 mechanisms that we're reallocating set points to evade cloud coverage and such. So still, it's certainly grouping panels. It's not at the panel level. Yeah.
Okay. And then the idea for these is just to reduce curtailment, or is there any flexibility that you can use to monetize somehow?
Yeah, certainly. So step one, the easiest sell for us is the reducing curtailment, because we can do that tomorrow. If we plug into your site, we will reduce your curtailment in those curtailment scenarios. But really, what this unlocks is that flexibility piece. So we're seeing in a few markets, including Duke Energy, and then as Tristan mentioned, ERCOT and CAISO, they're offering what's called flexible interconnection, which is the ability to interconnect quicker and at a lower expense by reducing your interconnection studies by promising a reliable curtailment. And so that's really what we're working towards, is allowing solar to be this controllable, flexible asset. And our software completely enables that right now. But depending on the market that you're going to, and especially, talking to EDP, for example, grid stability isn't the initial sell. It's reducing that curtailment and then offering that provision to the grid operator and getting back flexible interconnection.
Clear. Thank you.
Okay, thanks a lot. We ran out of time, actually. We went through it, over it. So thanks a lot, Tristan and Simon. We'll let you know the results in the next few weeks. Okay.
Thank you.
Great. Thank you so much.
Thank you. Okay, so last two pitches. We're going to have Yanis now from Electryone AI. Hi, Yanis. Welcome.
Hi, everyone.
Yeah. Hi. Hi, welcome. We are here with EDP and we're ready to hear your pitch. So yeah, you have 4 minutes and feel free to start.
Amazing. Thank you. Well, Electryone is an AI platform that enables energy companies to build intelligent flexibility products for customers with home energy assets like electric vehicles, heat pumps, and home batteries. The company was founded by me and Ioannis. Now I know what you guys are thinking. We basically have the same names. Before Electryone, we worked for companies like Palantir and McKinsey, scaling data and AI platforms. Large energy retailers today are facing a number of challenges: rising imbalance costs, low margins from the traditional tariffs, and inability to monetize household flexibility at scale. So this is where Electryone AI comes in. We enable energy retailers to launch new products that monetize flexibility from their customers' home energy assets. Companies using our software can seamlessly connect to various energy assets and forecast and simulate their behavior with a deep learning algorithm. And then they can automatically optimize their energy use based on the user's electricity tariffs and other energy trading opportunities to unlock significant bill savings for their customers. And finally, orchestrate these individual devices into a single dispatchable unit called a virtual power plant that can automatically deliver grid flexibility, generating new income from flex markets. Today, energy companies across Europe are powering their virtual power plants with the Electryone platform. They're monitoring their PV and battery assets in real time and forecast solar generation and consumption patterns and that power our off-the-shelf algorithms that optimize battery usage across different price signals, whether that's the OMIE prices in Spain or the Octopus Flux tariff in the UK, to unlock significant bill savings for their end customers of up to 150%. And then being able to trade this aggregated energy and flexibility into various markets and generate new revenue. Soon, our clients will be able to build their own optimization algorithms on the Electryone platform and deploy them in seconds, saving them millions in infrastructure spend and enable them to focus on what matters most, which is rapidly building and scaling innovative products for their customers. The pilot we propose with EDP is to trial an intelligent flexibility product for residential asset owners, whereby we will use the Electryone platform to provide local flexibility services to Portuguese DSOs from home energy assets. So we'll work closely with EDP to identify the asset types the pilot uses and the most appropriate enrollment UX, which is typically a mobile app. We will then onboard the user's assets onto the platform so we can monitor the performance, predict user behavior, and then identify trading opportunities to provide local flexibility services through the Piccolo DSO Flexibility Marketplace, which is live in Portugal and we're currently integrating with. And our platform will provide an end-to-end solution where we will pre-qualify, orchestrate, and automatically dispatch flexibility from these assets, provide local flexibility services, and generate additional revenue for stakeholders over a certain period of time. By the end of this pilot, EDP will be in a unique position to commercially roll out and scale one of the most innovative flexibility products in Europe and generate new high margin revenue for them and their customers. Thank you.
Thanks a lot, Yanis, for the presentation. It was right on time. So let's open for Q&A.
Hello, I can kick off with some questions. Just to understand here, either in the pilot that you propose and the platform as a whole, what you need from us is the assets and users to be on board in your platform, and then you run everything else, meaning you participate in the flexibility markets, or do we need to do that and you act just as an enabler, as a platform that allows for us to control that?
So correct. We deal with all aspects end-to-end for the pilot stage. And then beyond the pilot, we're flexible to work with EDP, depending on how they prefer, whether they want to be the local flexibility provider themselves or the aggregator and use our technology, or whether they want to use our service for that.
Okay. I had another question that I just forgot, but I'll get there in a second. So if someone else wants to jump in with a question, feel free to.
Yeah, I have a good question, Yanis. How many assets do you have under management?
Now we got thousands of batteries across 2 countries, Spain and the UK. So we have solar and batteries on the platform, and we'll soon be onboarding EV chargers and heat pumps.
And are you focused only on residential clients?
At the moment, yes.
Okay, thank you.
Someone else?
Well,
Andre,
I guess just one point that I wanted to mention then, we do have a specific pilot in mind that's quite ambitious, but I think it's a great fit for an innovative company like EDP, but we're quite flexible to find what the right pilot could be, whether that could be heat pumps, EV chargers, or other types of flexibility. We've built a highly configurable platform that can serve a lot of different needs. So we're keen to continue the conversation if it makes sense along those lines.
Okay. So time for one last question. Does someone want to jump in? Okay, so that's it. Thank you a lot, Yanis, for your presentation. And we'll get back to you with the results in the next few weeks.
Thank you for the opportunity to pitch.
You're welcome. Thank you. Bye. Okay, so the last pitch is going to be done by Benjamin from NarrativeWave. Hi, Benjamin. Welcome.
Thank you very much. Good afternoon. I'm guessing. How are you all today?
Very good. So you're the last one to pitch. We're ready for you.
Uh-oh. Just a little bit of pressure, huh? That's all right.
No, that means we have more time for Q&A.
Okay.
Okay, so we are here. You have 4 minutes and feel free to start anytime.
Fantastic. Well, first of all, thank you for your time. My name is Benjamin DCO. I'm the CEO of NarrativeWave. We're going to talk about very briefly what NarrativeWave does. We'll focus primarily on what we do in the renewable space with operators like EDP, although not EDP today, unfortunately, yet, but hopefully in the future. Very simply, we see data as your most valuable asset. What we do is focus on providing as much control to our customers from day one to impact critical use cases that are important to your business. The problems that we see with a lot of our clients that span Europe, North America, and now South America, as far as energy operators, is a lot of manual processes using spreadsheets, don't have the ability to control, can't build analytics on their own, and putting the power of analytics into the operators and the operations that control that, i.e., performance engineering teams that are managing critical assets, wind, solar, BESS, et cetera, right? And the other part of it is in renewables, every operator, doesn't matter your size, needs to do more with less, needs to automate workflow and operations. So how is it solved today? Well, in most cases, it's not solved today, or it's used spreadsheets, or there might be an old line closed monitoring solution that they're trying to do that's not effective. And so what we've done is we've developed not only use cases, but the ability for the operators to have control, as much control as you want in NarrativeWave, and that also provides time to value in a matter of days. So what's the customer flow? Very quickly, what we do is we deploy analytic packages that we've got in our different segments. Those get better and smarter based on more client engagements that we've got. So whether that's solar or BESS or wind or geothermal, for example, we deploy those analytic packages very quickly. Our customers have as much control as they want. So think of NarrativeWave as an in-source solution set, meaning your people can have as much control as adding your own Python code NarrativeWave, adding your own machine learning algorithms in NarrativeWave as you want. So it's all about an in-source tool set. And why is that? Every operator today says, I want to control my data. I want to have time to value very quickly. I want to do it on my own. And we're an enabler for internal teams to do that. The second phase of that is implementing automated workflow. So it's not uncommon that our customers see value on day one when we connect your data to your NarrativeWave instance. Now, the analytics may not be perfectly curated, but in most cases, that data has not been used in the way it will be in the analytics with NarrativeWave. And then the third component, which is probably the most important, is that the ability of engineers, performance engineering teams, for example, to have that feedback loop, to add their knowledge into the system so it gets smarter over time in a much more effective manner, right? So that time to value is allowing the engineers, your engineers, to put their knowledge into the system so it gets smarter over time and drive standardization. We're not going to get too much into some of the client examples, but what we focus on is let's get very tailored on what is the use case you're trying to solve. We'll talk about how quickly we do a rapid POC process, but to use an example, Carlyle Group used us for underperformance on their renewable asset companies, all focused on impacting underperformance, and we did that in under 30 days for them. Where do we fit? We fit in directly into your systems. We do not change anything on your systems. We tap into whatever data source that you have. Again, we focus on performance engineering teams. By extension, there's the analytic teams, field service, et cetera. And then the use cases, I'm not going to get into too much detail, but clearly use cases that we can and should be considering to solve for EDP. Not going to get too much into the automated packages. Oops, sorry. But one of the key things you should take away from here is what we do is we do what is called a rapid POC process. It's less than 2 weeks. Take a subset of your data, show you outputs in NarrativeWave. And what that does is two things. One, it's a use case validation for you, and it shows the implementation success ahead of time, so there's not any surprises once you go into an engagement with NarrativeWave. Why NarrativeWave? Time to value, data-driven decisions for your engineers, and immediate use case value creation. Okay, so I think I'm done there. Am I allowed to continue on? That was pretty quick. What questions can I answer for you in that very quick overview?
Okay. Sorry, I didn't understand. Do you want to continue very quickly, or are you done? Sorry.
I think I'm done. Was that helpful?
Okay.
Quick?
Go for it.
Sorry.
Yeah. Who has questions for Benjamin here?
Hi, Benjamin. Thank you so much for your explanations. Just one question on the in order to extract the most value possible from your platform, what do you think is the size or number of assets or megawatts, gigawatts, whatever, that amortize the cost of your setup, process, implementation, and analytics?
Great question, Jorge. Actually, we don't care about the size. We have operators that are small, to call them $25,000, $50,000 subscriptions, all the way to our very large operators that are like EDP side, like RWE or Enel. So it's right-sized. From our vantage point, it's treated the same. It doesn't matter the size. And that's why we go through a quick, rapid POC process so that you can see, in essence, the use case in NarrativeWave with your data and very quickly get a sense of, okay, this is how we're going to implement it. What we find in every engagement, there's things you need to learn before you start the implementation, right? So that time to value is part of it's the software, but part of it is making sure that what our customers want to leverage in that use case, how they want to leverage the outputs, how they want to leverage the actual impact to operations is very much effectively learned through that initial POC process that we do not charge for. We literally say, all right, give us a subset of data on this. We'll stand up an instance of NarrativeWave. We'll show you the outputs that they won't be perfect, but it'll give you a sense of validating your use case, validating how it'll be solved, and that gives the precursor for the implementation. But back to your question, we right size it to whatever it is, regardless if they have 100 megawatts or they've got 15 gigawatts, frankly.
That's great. Can you go back to the slide on the pilot proposal for the stages, the one with the weeks and months? Yeah, that one.
Yeah. So this is a good slide because we're a firm believer you should see time to value in the first couple of weeks. This is actually after the POC. And so it's not uncommon, as I said pretty quickly, that our clients see value on day one because they haven't used this data for these outputs, right? And again, this is easier to be discerned and seen through a quick demo, but the ability to put the power of NarrativeWave into the performance engineer's hands, to have that control and to automate areas that they need for your operations is what's critical. This is our ongoing process of, even, I don't care if you're some of our largest clients, it does not take our clients more than typically an hour every 2 weeks ongoing, right? It might be the first 2 months, we meet an hour a week, but it's about coming in, validating. Your engineers have as much control as they want. If they want to control and build analytics, they can. If you want our data science team to do it for you, we can do that as well. But typically, you're seeing time to value in the first couple of weeks, and then there's curation and adding feedback based upon your subject matter experts. Does that make sense? And so we just kind of show this as, and what we hear from all of our clients is, wow, one, we've never had these outputs, but two, we have control. The biggest complaint we hear about other solutions that are out there is, I can't change this for this site, or this site needs to be different, or this threshold is different. So you have as much control, your engineers have as much control as you want. The other part of it is, you want to be able to change things on the fly in a matter of minutes. And you want to be able to do that without NarrativeWave. If you look at traditional old line monitoring companies, that takes months. You got to change this. It's not set up to do that. So at the end of the day, when we say self-service, you have as much control as you would like.
Okay, thank you. I was about asking about the pricing model that you have and so on, but we're running out of time, and maybe we have time next week, Friday.
Yeah, definitely. Keep it simple on the subscription-based pricing on an annualized basis. It's right sized to megawatts, gigawatts, and what we recommend is start small, nail the use case, and then grow as you want. So a lot of our clients will say, all right, we've got 5 gigawatts. Great. We'll start on the first half a gigawatt, and then it's very easy to expand from there based on tags and everything else on your asset portfolio.
Nice. We will have more time this week, Friday, with our colleagues in Brazil. Thank you.
Fantastic. Thank you for the questions.
Hey, wonderful. So thanks a lot, Benjamin, for the presentation and for answering the questions. We'll get back with the results in the next few weeks. Okay. Thank you for being here today.
Thanks for having me as well. Take care. Cheers. Bye-bye.
You're welcome. Bye. Okay. We are done. We made it. Congratulations to all. It was intense. 2 intense days. I don't know if someone wants to comment, if someone wants to give their impressions of how the pitches were, or...
No, I think we only have a few leftovers here. But no, I think the pitches were good. I think it's great that none of the startups were missing this time. I think that was a positive side. And in general, I think the startups were well prepared and yeah, everything went very smooth. So thank you very much to everyone that participated. This long marathon, and we're looking forward to hear the feedback from all of you.
Okay, just one question. Thank you, Vasco. Just one question, Margarita. For some couple of colleagues that were not able to make it, when do you expect to have the recordings ready for us to forward the links?
So tomorrow I'll send the link to Vasco tomorrow. Yeah. So you can watch it on YouTube. Yeah. You'll have all the recordings.
That's great. Thank you so much.
Okay. So thanks a lot, everyone. Thanks for the participation as well. And have a good rest or lunch nap or yeah. Thank you.
You too. Bye.
Thank you all.
Thank you.
Bye.
Thank you very much.